A very good morning to all of you who are joining with us today as we eagerly wait an exciting morning. The Department of Manufacturing and Industrial Engineering. We have a purpose of fostering an academic environment in which research and innovations can flourish. Without research, we will not rise to the heights of our potential. And that's why we present you Industrio 2021, the annual research and project symposium organized by the Manufacturing Engineering Association of University of Peradeniya. Today, you will be witnessing the outcome of research done by final year students of the Department of Manufacturing and Industrial Engineering under the topics of manufacturing automation, manufacturing engineering, logistics and supply chain, life cycle assessment and management. As a department, we have come a long way, surpassing many challenges and hurdles. We are proud to be able to host this virtual event, even at these difficult times where everything is moving towards the virtual world due to the unforeseen and strange circumstances caused by the COVID-19 pandemic. But still, we are delighted to see our dignitaries, guests, lecturers, industry experts, and students excitedly gathered to share and gain knowledge. Because rarely would you find this kind of a gathering saturated from experts in one place. So, in order to formally begin our proceedings for the day, I would like to invite Mr. Sumudalakkana, the Vice President of Manufacturing Engineering Association, to deliver the opening remarks and to welcome you all. Over to you, Sumudu.
Thank you, Kulani. Good morning to all of you. Industrio is a platform for all final year undergraduates of the Department of Manufacturing and Industrial Engineering to present their final year projects and research. Today, we are all gathered here virtually to witness the final outcome of the research and projects done by the final year undergraduates of the Department of Manufacturing and Industrial Engineering. On behalf of the organizing committee of the Industrio 2021, as the Vice President of the Manufacturing Engineering Association, it is my honor and privilege to warmly welcome our Chief Guest, Engineer Jagath Jayasundara, CEO of Advanced Electrical PLC, and our keynote speaker, Professor Gamini Dissanayake, an emeritus professor from University of Technology, Sydney, to Industrio 2021. I am also pleased to warmly welcome Dr. Dissanayake, Dean of the Faculty of Engineering, University of Peradeniya, to Industrio 2021. Furthermore, I would like to welcome Dr. Asela Kulutunga, Head of the Department of Manufacturing and Industrial Engineering, Faculty of Engineering, University of Peradeniya. Also, I would like to welcome the panelists of panel discussion of the Industrio 2021. Mr. Sanjeewa Jayasundara, Head of Supply Chain Management at Ceylon PLC, John Keells Holdings. Mr. Thilan, Samarawickrama, Director, CEO, Ecopin Private Limited. And Ms. Sithila, Dassanayake, Director, Technology Innovation, Twinery by MAS. And Mr. Priyantha, Factory Manager, Regnis Appliance Private Limited. Also, Mr. Maleen Jayasuriya, Temporary Lecturer, University of Peradeniya. I am also pleased to welcome all the members of Industrial Advisory Board of the Manufacturing and Industrial Engineering Department and Executive Committee of Association for Professor Sanatunga Memorial Fund. Also, I would like to warmly welcome all postgraduates, academic staff, the faculty, and all other distinguished invitees to the event. We are extremely honored and grateful that you have taken out your valuable time and join us today to be part of this. Industrio is the best platform to our final year undergraduates to present their work to industry experts. Even in this challenging period, final year students have finished their work successfully. So today, you will be able to see their work. Finally, hoping that today's event will be an immense success, I welcome you all again to Industrio 2021. Thank you. Over to you.
Thank you. Thank you very much, Sumudu. Once again, a very good morning to all of you who are joining with us at Industrio 2021, a project and research symposium organized by the Manufacturing Engineering Association. In order to create an excitement as to what our content for today will be, we are honored to have our keynote speaker and our chief guests who are willing to share their immense knowledge with us today. And not to forget the main event of the day, the presentation of research and projects done by the final year students of the department. Furthermore, we will be talking about how manufacturing and industrial engineers contribute to the sustainable transformation of the industry with experts of the field in a panel discussion. Subsequently, without further ado, I would like to invite Dr. Asela Kulutunga, the head of the Department of Manufacturing and Industrial Engineering, to share his thoughts. Over to you, Dr. Asela.
Yeah, thank you very much, Kulani. Very good morning to you all again. Today is one of the memorable days for DMIE, or Department of Manufacturing and Industrial Engineering, because this is the first time we are going to organize student project symposium online mode. However, we used to do this some time back in different other events in parallel to international and local arena. However, due to COVID, now we had to switch into the online mode. So this is a bit challenging event for the department from the beginning, because we didn't have students in person in the department most of the time, or throughout the last 2 years almost. So first of all, I would like to thank the MEA, Manufacturing Engineering Association, for initiating this activity this time to have the student symposium online mode. Actually, this was one of the events even we thought of having annually some time back, and even some of our industrial advisory board members also suggested to have such a thing to showcase some of our ongoing and current research happening in the department. So with those valuable inputs from some of the industrial advisory board members, we thought this is the right time to have it, since we can logistically operate in online mode, so that wider coverage can be achieved. So that is witnessed today, because now today we have very two eminent personalities connecting from different parts. So first of all, I would like to warmly welcome on behalf of the Department of Manufacturing and Engineering academic staff, Mr. Jagath Jayasundara, the CEO of Advanced Electricals. He is one of our proud alumni from the department, currently heading that division. With his busy schedules, he anyway agreed to support us for the betterment of the department and to inspire the students of the DMIE. And also, I would like to specially thank our keynote speaker, Professor Gamini Dissanayake. He's one of the eminent professors in the world when it comes to the mobile robotics, and I had the privilege of working under him some time back. So his training was so valuable for my academic career. So I'm very indebted for him, as well as I am very much happy to have him here today as the keynote speaker, because he really tried to drive the younger crowds towards some of the emerging technologies like mobile robotics, etc. Because currently he's helping us as a visiting professor in the department, though he is not physically here in the faculty. And also, I would like to thank our Dean, Dr. Dissanayake, who is always supporting this type of activities, especially to promote department activities among the industrialists, as well as to motivate the students who are struggling at the moment to switch to the online mode. So, however, with those inspirations from the faculty administration, especially from the Dean, Dr. Dissanayake, we managed to hold almost all the events we planned to have within the department, and this is one of the main events we today we are going to witness. And also, I would like to thank especially our emeritus professor, Professor Susantha Pathirana, who is joined with us, even though he is also busy with some of the activities during the weekend. So thank you very much, sir, for your presence. And I would like to also thank our industry advisory board members who are joining with us. Some are joining as a panelist for the event as well. So thank you very much for Ms. Sithila Dassanayake, Mr. Sanjeewa Jayasundara, Mr. T.G. Veerasinghe, Mr. Ashoka Vandara, Mr. Priyantha Wettewa, and Mr. Thilan Samarawickrama, always supporting us, even though he is away from out of the country for many years now. So thank you very much, Thilan, also for joining with us. So last but not least, I would like to thank all the academic staff members who are joining here from the department, as well as the students who are connecting with us, not only from MIE, even the first years I have invited just to witness what DMIE students are doing for their undergraduate research and project components. So finally, I would like to thank especially the MEA committee for organizing this one, especially the leader of the MEA, the president, Dr. Achala Pallegedara. Actually, he organized this single-handedly with the support of students who are not in the faculty. So I think you will be able to see very good, fruitful event to come. So thank you very much for all your presence, as well as contributing in time to come. Thank you very much.
Thank you very much, dear sir. Thank you for your support today as well as every day. Your advice, networks, and the relentless support is very much appreciated. You are truly a source of inspiration to us. Now it is indeed my pleasure to cordially invite another guest, whom we are sincerely honored to have here. Dr. Udaya Dissanayake, the Dean of the Faculty of Engineering, University of Peradeniya. Dear sir, I invite you to share your thoughts on Industrio 2021.
Thank you very much, Kulani, can you hear me?
Yes, sir, we can hear you.
Good morning to all of you again. So during the last almost 2 years, we have been going through a very, very difficult time. And I am glad to see as the Dean Engineering that we were able to overcome most of the obstacles we came across, and we were able to finish the academic work pertaining for 3 semesters since February last year. So I think the batch who is presenting their project work now, they have done last 3 semesters of their degree program were mainly online. So that is actually a very big challenge for both the students and the staff. So I would like to first of all thank the students for taking that challenge and supporting us to finish this academic work in a successful manner, especially the finishing the project work in the 7th and 8th semester is very, very difficult without the physical presence at the faculty, but still I can see that you have done very good work. So congratulations and well done. And also for the staff also, it was a very, very challenging time. So I know that there are a lot of relatively young staff members in the DMIE, and they are working very, very hard with their head of the department. So I think together you have done an excellent work. So with the COVID-19 changing its face and continue to give different challenges every day, is the topic of your research symposium today is very, very appropriate. Without sustainability and without changing the lifestyle, I don't think we can tackle this situation in the long run. So we also have, it's essential that we have developed the research work to see how we can live together with this pandemic situation. So at the same time, this research work is very, very essential to maintain the global and the local position of the university, especially the ranking of the university, because in this competitive educational environment, maintaining the rank of the university is very important. So, so it is, I am very happy to see that Professor Gamini Dissanayake, who is an emeritus professor from University of Sydney, is serving your department as a visiting professor. So I think during our time at the university as students in early 1980s, mid 1980s, Professor Susantha Patirana, Professor Dr. Katupitiya, and Professor Dr. Gamini Dissanayake were legendary characters. They were young lecturers at that time, and we look up to them very interestingly at that time. So it is good that you continue to get their support to your department all the time. And I would also like to thank Mr. Jagath Jayasundara, the CEO of Chief Executive Officer of Apache Electrical. Your support to develop the budding engineers in the department is very, very valuable. So there are a lot of other members from the industry. I think without this close collaboration with the industry, it is very difficult for an engineering faculty to survive. So your valuable support to the department is very much appreciated. Then finally, I would like to thank or congratulate MES Manufacturing Engineering Society for this valuable work, and also would like to thank Dr. Achala Pallegedara for organizing this event. I know how difficult it is to organize something like that in a challenging situation we have at the faculty. Thank you very much, and I wish you a very fruitful day. And again, thank you very much for inviting me to give share my thoughts with you at the beginning of the event. Thank you very much.
Thank you very much, Dr. Uday Dissanayake, the Dean of the Faculty of Engineering, University of Peradeniya, for being here to motivate us. An interesting event is coming up your way now. Let me introduce to you our keynote speaker for the day, and please give me a moment of your time to read out his profile. Professor Gamini Dissanayake is an emeritus professor of Mechanical and Mechatronics Engineering at University of Technology, Sydney. He is the founding director of internationally acclaimed robotics research group, the UTS Center for Autonomous Systems. And we can proudly say that he did his undergraduate studies in our department. After graduating as a production engineer, he received his MSc in Machine Tool Technology and PhD in Mechanical Engineering from the University of Birmingham, England. His main contribution to robotics has been in simultaneous localization and mapping, a technology that underpins many robot applications. His work in this field has resulted in one of the most cited journal publications in robotics, which is used as a reference by robotics students worldwide. He is a highly cited researcher with more than 300 published journals and conference papers. Ladies and gentlemen, to address you at Industrio 2021, I have the immense pleasure of handing over to Professor Gamini Dissanayake to deliver the keynote address. Over to you, sir.
Thank you, Kulani. Thank you for that kind introduction. It's my great pleasure to be here talking about what we've done in the past few years and to this audience. So given that, this is, we are trying to showcase the research of our students, and this is in fact the capstone of their studies at the university. They're bringing in everything they've learned in the past few years into addressing a challenging problem. Some of them are industry inspired, some of them are actually industrial problems, some of them are basic research issues. So I thought it's opportune at this time actually to talk a little bit about university industry collaboration and what I see in there. So let me start a presentation. I'll share my screen. So are you seeing the screen there?
Yes, sir, we can clearly see the screen.
Okay, so definitely, from my point of view, the collaboration between industry and the university has a great role to play in the economic development in any country, in any setting. So what I'm going to talk a bit about is what is my view of industry-university collaboration? Why is it a win-win situation for both the industry and the university? And then I'll draw on some examples of some of the work we are currently doing with the Department of Manufacturing and Industrial Engineering, Peradeniya, and also some of the work I have done in the past in Australia. So the main role of the universities, of course, as you know, is educating and training our future workforce, so that we are generating an asset that will be out in the industry, especially in the engineering context. And as already been mentioned, research is a prime part of university activity as well. So this is discovery and dissemination of knowledge. This is about learn a bit more about the world we are living in, find better ways of doing things that we can do, and sometimes actually find ways of doing new things. So this is the university contribution. Industry, in a sense, takes something, some raw material or some process, and add value to it to generate some wealth. So the wealth generation is the key goal. And of course, that generates economic benefit, and there's a societal benefit because the industry, whatever the output could well be for the benefit of the society, the employees are part of this wealth generation, so they'll be taking home money which will feed to their families and to the overall economy. Collaboration between these two entities are actually intrinsic. So for example, if we take our role in teaching, we already put students in industry placements. So they spend some time in industry to gain an experience of what is actually happening out there in the world and relate what they learned at the university to the actual job they have. And when they come back, they actually come very well motivated, recognizing the value of some of the things they have learned and appreciating that, and also actually finding out what they want to do, know more, and actually interrogate your academic lecturers to learn a bit more about various things they have seen in the world. In terms of, so that's the obvious interaction. We also have guest lecturers from industry. They have wealth of experience in the field. They can come and talk to students to motivate them and give them an insight into what are the real challenges out there and the life in industry. We also, as you see there, we have various projects, and you have seen that some industry projects through the students. So some of the projects you're going to see are industry driven, some of them are industry inspired. So what is the next step? What is the what is the benefit we are going to get out of that? Industry always, as I'm sure you all know, you don't stay in one place. If you stay in one place, you're losing competitiveness. So you're always striving to do better and better of what you're doing. And sometimes it's possible to do what you need to do in-house. You have the expertise. You can you always look forward to what are we going to do next year and year after, and you can achieve that. On the other side, when that expertise is not there, the structure is set in the university, especially I know at Peradeniya, that you can actually tap into the expertise that is available either through the academic staff or through students. If you're thinking about looking at something even more long term, you can maybe, even though the capacity is there in-house, you can try and explore some ideas with student projects and see, okay, with very little cost to understand what it brings. So you can explore things, and of course this brings a huge benefit to the university. It helps train our students well. They are getting exposed to real industry problems, and as I'm sure you will see some of these things today. So to me, a collaboration between the industry and university is a win-win for both sides. So the university gains by being able to contribute to the industry, as well as being able to educate our students and train our students better. On the other side, the industry hopefully got to be involved in that as a benefit, because they can outsource some of the things they don't have the capacity to do. They can use students as exploration, and sometimes actually these students who are engaged in industry projects are potentially the next employee at the industry. So you get an opportunity to test some of our brightest talents to see whether they actually fit your culture, whether you want to get them to come and work for you. So this is what I see as the value of this collaboration, and how it can bring economic benefit to the country. So what I want to do next is to talk a bit about some of the work I'm currently doing and I have been involved in the past. So just to give you a background, I don't want to go through all this. I was at Peradeniya, as Kulani mentioned, and it was actually the first group of students to do production engineering in their final year. So this was a very long time ago. This was 1976. Professor Patirana was the year after me, who did both 2 years of production engineering, whereas we only did 1, and graduated with what's very strange. It's the only unique degree from University of Peradeniya which says production biased mechanical engineering. So that's an interesting thing. Then I've been around. I was at Peradeniya for a while after postgraduate studies. Then I was in Singapore, in Australia. And last year I retired from University of Technology, Sydney, where I'm now emeritus professor. And I thought that's the great opportunity now, having spoken to a sailor who I know very well, to say, okay, is it possible to make a contribution to University of Peradeniya? And one good thing COVID has brought us is to tell us that you can actually work remotely and still be effective. So this is great. So I'm in Australia now, it's in the afternoon. and I'm talking to you, and I meet with the students and staff at DMIE regularly to talk about projects. So let me give you a brief rundown of what we are currently doing, just to give you the flavor. This is very early days yet, so I'm not going to I don't have too many things to say in here, but I'll briefly mention what we are trying to do and why we are doing it. So one of the things we are looking at is a mobile robot for material transfer in factories. These are very common around the world. The whole idea is to have a machine that move goods around to facilitate that material transfer. So if it's, and it's actually widely used in many industries. I mean, if somebody in Australia wants one of these, then you go and potentially commission a automation house and say, look, you come and install one for us. So if it's widely available and we are a university, why are we looking at it? I think the key word here is the low cost. And in fact, keyword in the collaboration in any setting is the appropriate technology. So we need to think about what we are doing. Is it acceptable to the local environment, to the client or to the industry partner we are collaborating with? You can buy one of these, but it will cost you two or three beautiful cars. So now the challenge is, okay, is it possible to do something better? So much of the cost of these robots actually come from their sensors. So when you move around, you look around with your eyes and you process what you see and you decide how to move and so on. And to do that for a robot, typically to do it reliably, you use these laser sensors, and they are quite expensive. And the low cost ones have poor accuracy, or it's very difficult to understand what's going on. So the idea here is to see, okay, so maybe we can do it with the cheaper set of sensors with some smart algorithms. Sometimes you think, okay, if it can be done cheaper, why aren't these guys doing it? So which is actually true. So one of the appropriate things we're thinking about is, okay, is it possible to somehow trade off a little bit of reliability, maybe not 99.9%, maybe 99%. So some little bit of manual intervention to reduce the cost drastically. Is it possible to structure the environment a little bit, put a marker here and a marker there, rather than having a free factory flow to make it cheaper? So this is the objective. So now we have a couple of research assistants who are research engineers at the department who are working on it with multiple academic staff members providing the support. So this is something we look at as an industry inspired project. So you think that there's a potential value here. And in fact, actually, if we make something really good, this could potentially be useful in many other places outside Sri Lanka as well. So based on the experience, we see the value, and although we haven't really engaged an industry partner, we are looking at it. Another thing, actually, this is in collaboration with the archaeology department. We are looking at cultural heritage preservation. So, as you know, Sri Lanka has so many monuments that are more than 1,000 years old. And they are all, much of them are exposed to the outside world. They are deteriorating a little bit. And given the climate change, given the intensity of all the natural events that are increasing, the danger is there that these things will these are deteriorating, and we want to preserve them for the future generations. So how do what are we thinking about doing there? So the idea here is to get information about these monuments using some 3D modeling and looking at condition. Okay, what is the color at a given point? What is the humidity? Is there anything we can say about the internal structure at a point? What is the shape? So we capture these things. We are attempting to capture all these things, and then you can analyze it in detail in your office, but also in maybe 3 months' time, maybe 6 months' time, you go and do it again. And then you look at exactly the same spot with exactly the same instruments and see what the change looks like. Is there a change there? Is it possible that this change is actually something significant? So can you actually capture this change before it becomes drastic, so that we can take some corrective action? So through Ceylon as one of the drivers in here, we are talking to the Director General of the Department of archaeology, and we've actually now put forward an application to the ambassadors fund from the US Embassy to start up a project in this area. So that we've written the proposal, we thought through what we're going to do, and now we're waiting to see how it pans out. But the interesting thing about these things that once you've done something like that, now we can potentially use the undergraduate population next year to do some scoping, get them excited about a problem like that. This is a real life problem for Sri Lanka. So can we do something here? Can we make a contribution to our country and our cultural heritage? There's another one, which is, I'm sure you all know that the human-elephant conflict is a really big thing in Sri Lanka. So this is something I'm doing with your electrical engineering department, Professor Lilantha Samarawickrama. So the idea here is that, okay, elephants get hit by trains, and it's not very often, but when it does happen, it's actually, it's frightening to see what's happened. There's a humanitarian side to it and the animal welfare side to it, where elephant get hit and killed, which is really nasty. On the other side, an accident creates a huge damage to the locomotive. On top of that, because there's a potential for elephant train collision, in many regions, the trains actually drive quite slowly. You spend a lot of energy just doing exactly the same thing. So, it adds delay to your travel. The cost is increased. So SLR obviously has a challenge in its hand. So this project is actually started talking about maybe 2-3 years ago, and we managed to get funding from overseas a couple of times. Once from a humanitarian fund of the IEEE, and then we got some funding from NVIDIA, which is the video card manufacturers, to use theirs, and they gave us a bit of money and bunch of their hardware. So and now Dialogue is involved in contributing this. So now there's actually a team in electrical engineering. We are building a device which looks at the terrain and detect whether there is an elephant in there, and then provides a warning to the driver. So one idea is to put this in a hotspot where we know elephants travel, and if there are elephants in that spot, we warn the approaching train driver to say that now is your time to slow down. On the other hand, we are also playing around with installing this in the cabin to see whether our elephant detection algorithm does a better job than a driver in detecting it from far away. So is it possible then to slow down? I mean, there are many challenges, but that's the interesting bit. Nobody knows the right answer, and we are looking at this problem to see whether we can make a contribution. And of course, the next step is to think about the broader elephant-human conflict. But this is something for us to look in the future. We looked at with TRI this idea of tea plucking. As you know, the value of quality of our tea is because the leaves are plucked carefully by pluckers, and you only pluck the right leaf, and only a few of them at the right maturity. Now there's a significant labor challenge there. Young generation doesn't want to do this. It's hard to do, and they're looking at systems for doing this. There are machines in the world that will do cut leaves of a tea bush, but they just go out and just cut it like you trim the whole tree. That's okay for low quality tea, but that's not good enough for high quality tea, which we are accustomed to coming from Sri Lanka. So this is something, again, we looked at as a problem. We talked to TRI, and now we put up a proposal to Amazon, one of their research funds, to see whether we can get some money from these people to make a start on this problem. This is a challenging problem. This is long term. And another one we are looking at is a kind of a perimeter security system. Again, low cost is the key word. I mean, if I want a proper perimeter security system here, I'll go out and buy a bunch of cameras, install them, attach it to a Wi-Fi, and I can see everything what's going on. But if that's too costly, what are the other things? Are there other sensors that can do this job for us? So this is the kind of thing we're looking at. So this is a flavor of what we are now planning together with Achala and his team to look at collaboration with some real industry problems and also some problems with social benefit like the cultural heritage. So that brings me to talk a bit about what we've done in the past. I think the key here to remember is that what I have done in the past is targeted at the Australian environment. You might look at it and say, we're not going to be able to do this. This is too expensive. These are really complex systems, but that's not true. The systems are complex, but the main cost of developing something in this country, in Australia, is the cost of the labor. I hire an engineer, it probably costs 10 times more than what you have to pay in Sri Lanka. And then we have occupational health and safety, insurance. So the whole infrastructure is expensive. Equipments are fortunately becoming cheaper and cheaper. So I just give you that warning to say that, you know, some of this may not be appropriate. I realize that, but some of this, if there's an application, it's potentially suitable. But again, mention is the appropriate technology. What is the right for the local environment? How much are you prepared to pay for one of these robots? And that has to be the target if somebody is doing some research on building one. If you, I'll give you a nice example. So when iRobot developed its first vacuum cleaner, they went around asking people in shopping malls, asking them, how much would you pay for something without having to talk to your spouse? Is it $50, $100? So how much are you prepared to pay without thinking about consulting the family and thinking about, this is a big expense, so I better talk to my wife or talk to my husband? So the answer came as, I think $100, $100 US. If people said, if it's less than $100 US, if I think it's good, I'm going to buy it. So what the iRobot did is actually set the scene for their team to say, look, I want you guys to build a vacuum or robotic vacuum cleaner, but it's got to be cost less than $100. And they did. It doesn't do everything really well, but it was low cost at that time. And they sell thousands and millions of them. So this is the message. I think what we are doing got to match the environment. So here are some examples I've been involved in to again match the environment where the industry partner had a need and they wanted a solution and they didn't have the in-house capability for doing it. And they came to the university to say, can you look at this? So the first example is the steel bridge. This is the Sydney Harbour Bridge, a beautiful, it was built in 1932. It's got these great big girders. And these actually they are box girders. So there's a hole inside them. And to inspect them, you've got to go through this manhole. And this is the cavity you are in. So you can, and this is what you have to do to get in there. So it's a big space, but it's still very confined. And you have to sometimes go through these things called manholes and inspect and get out. And the idea of the inspection is to see how much rust is there. This was how it was done earlier, but now Australia has occupational health and safety laws that tell you that if something goes wrong, if something happens to a person, that person needs to be able to pull out from there into an ambulance in a certain amount of time and in a certain period of time. And this is challenging. So this is called a confined space, and it's not, now you can't send people in there. So how do you inspect it? And they came and talked to us and started funding, gave us some funding. The Australian government gave us some funding to build a machine. So we built one. So this is a user interface. It was designed so that it can be operated by a bridge inspector, not a qualified engineer with a BE or PhD. So it goes in through that manhole and gets hold of the steel, and it crawls on its own. So there's no remote controller here. You just press the button and it moves on its own. And while it's moving, it takes images. It takes images of the environment and collect them and present them to the inspectors. This is recorded, and then once you come out, you have that record of what you saw there. Just like that cultural heritage example I spoke to you about. You can go, I mean, if there's too much rust, you got to do something about it. But if there's no rust, or if you see a minor damage, you can go again and inspect it, and you know exactly how it was 6 months ago or 1 year ago. In fact, this bridge doesn't get inspected that much. But the next example where we looked at concrete box girders, this is well, I'm sure this is common in Sri Lanka, and I think we have great big cavities in our dams, but they are much bigger than this, so you can potentially manually navigate in them without any trouble. But here is a bridge structure, arch structure. Sorry, it's a beam. It's a box girder. And what happens in inspection is that you crawl into this space. This is small, and take photos. And if you see a crack or something, you take a photo. You put a chalk mark near that, and then you come back. And maybe and if the crack looks quite nasty and long, maybe you think, okay, I got to go and do something about fixing it. But more often what they do is that they go in another 6 months to see whether it's actually propagating. Is it going to be a problem? So then they go to the place, go somewhere nearby, take an image. So this is one, it's kind of haphazard. The other one is it's again hazardous. So they came again, the Roads and Traffic Authority came to us, say, can you look at one of your robots and send it in to see what we can do? And we actually had a robot in the lab, and we used it to go in and map and inside an arch and collect images. And as I said before, you can go to exactly the same point, collect the same image, you can measure the length of the crack, and you can see what's going on. So we use some of the robotics ideas to do that. So here is another, let me see how the time is. How much time I have? I forgot to. Okay, sorry. How much time? How much time I have, Kulani, just so that I know?
We are actually a little bit behind the schedule, but that's fine, sir.
No, but tell me, because I mean, I'm not the main show here. The students are the main show, so I don't want to take their time. So how long before?
If you take 5 or more minutes.
So how much?
About 5.
5 minutes. Okay, yeah, that's fine. So because this is not an ending presentation, I have so many of them. I can just talk and stop whenever. So I stop in 5 minutes. Okay, so here is another interesting problem. This is again local to Sydney. Sydney has holes. I'm sure Sri Lanka do, and we have all these buried water pipes. And here they have been laid about 100 years ago, and they are cast iron pipes. So cast iron corrodes, or any iron corrodes when you bury them in the ground. The problem with cast iron is that it's a brittle material, and it suddenly blows up. If the corrosion is too much, it just blows up and creates whole lot of damage. So Sydney Water is having some of these issues, and they wanted us to look at, can you guys do something about measuring what's in these pipes and come up with the method for estimating how much life is left in this thing, or how probable is this that this pipe is going to fail. So this became a collaboration between 3 universities. Robotics is us, University of Newcastle has corrosion experts who knew a lot about how corrosion happens, and the University of Monash had the civil engineering expert. Actually, the civil engineering expert is one of Peradeniya alumni, Jayatha Kodikara. So he's a professor there now. He graduated maybe, I'm not sure, maybe 5-6 years after I did, I think. So anyway, the machines are buried. The thing is buried 1 meter underground. So we built a robot. So the application scenario is that when the pipe breaks, what's most important for the Sydney Water, at least at that point, was to make sure that it doesn't break again in the near vicinity, because then there's going to be a lot of trouble through politics and everything. Why can't you guys fix this thing? So they wanted us to go in and measure a pipe after a break. And there's usually a 2-3 hour gap between having a break and the repair. And before that repair, can you send a robot in and tell us what's happening? The problem with these pipes is that they have a cement lining inside. So it's not easy to measure things because you can't touch the steel. So we came up with a sensor system that allows us to do it. And then we can go in and come back with this what we call a wall thickness map, which the civil engineer can analyze and come up with the breaking strength. So in here, what you get is, this is a corrosion spot. So there is a place where the wall thickness is quite low, and these look fine. So getting this information allows you to assess the condition of this asset and decide what to do. And then obviously you want to stop pipes breaking. That's the first before you break. So they've asked us to think about having a machine which has a much longer range, 500 meters, but can go in during a planned shutdown. And we built one of these, and both these are currently in use at Sydney Water. Now they've come back again to say, look, how about a machine that do exactly the same thing, but without a shutdown? Can you actually get something in through what is known as a hot tap? So you tap a pressurized pipe through with a little machine, and you can attach a 150 millimeter shaft pipe to it. And you can put a valve there. So you can do all this without switching off the water supply. Now the challenge is to build a robot that goes to that 150 millimeter pipe and go into the pipe and do the same thing. So even though I'm retired, I'm actually, so this is a project we got just before I left, about 6 months before I decided to retire. So I'm still working on this 1 day a week at UTS to deliver that. We are not there yet. We're now testing some prototypes. Okay, so I got another minute, so I can show you. Okay, another problem with bridges. Sydney Harbour Bridge, it's a steel bridge, and it's got paint. It's lead paint, actually. So when you want to take, and even though there's paint, now there's rust in places. So they have to take the paint out, take the rust out, and then repaint. Taking lead paint out is difficult because it's hazardous. You don't want to let it escape to the environment. So you have to cover the area you're taking the paint out. So it's dark and it's dusty, and you can see a person using a grit blasting gun. This is a common industrial process where you actually drive a stack of garnet, little stones to the structure, and it cleans the whole thing. So basically you do that, but you're holding that gun with about 100 newtons force, and you got to do it in all postures, just like what you've seen. So this is challenging, and this is you're potentially exposed to the dust, and it's backbreaking. So again, we were asked to build a robot to see. So this is the final outcome of that project. So we built a robot which we can put where a person is in the covered environment, and it looks around with a sensor to work out what's around it. Although we have a design for the bridge. This is 1932. The drawings don't match what's actually out there. So we got to measure what's around us. So we measure what's around, work out the shape. So we use some of the prior knowledge that this bridge is not. We know what the structure looks like. All we need to do is take some measurements to reconstruct the structure, and then we work out, okay, how do we go about cleaning this? And we have to plan paths. And when we do this, because we have this grit blasting gun, you can't point it at anything soft, because that will go through it. In fact, if you get hit by one of these, that's the end of it. So normally when the grit blasting operator works, you have two people, one person to hold the gun and another person to hold the dead man switch. So if something goes wrong, if the blaster is incapacitated, the other person can stop. So here now what's happening is that we build the robot. It's not fully autonomous. It does its planning, then it shows that map what it's going to do to an operator, and then the operator is happy. He hits the button and say go and do it, and then it does about 95% of the work, and then the operator then goes into that kitted up and do the rest of it and finish off. So these are some of the examples I've been working with, and this is the motivation I have to take whatever the research we are doing into real life, into the field, and make a contribution to the community and the economy by doing that. So thank you for listening. I stop here.
Thank you very much, sir. But please stay as you are, because there may be questions coming from our attendees. So I would like to remind the attendees, if there are any questions you want to forward to Professor Gamini Dissanayake, please simply raise your hand, so we will let you speak. Or otherwise, you can type your questions in Q&A section.
Hello, Professor. This is Prasanna. Can I raise a question?
Yeah, I can hear you. Yeah.
Yeah. Professor, thanks for a very interesting presentation. Well, I think I'm trying to represent the entire manufacturing industry engineering group. Like it was quite interesting to see that how you try to connect different disciplines together. Like probably someone would think we are into manufacturing and industry engineering, and like how do we really see this big picture of connecting different, like you were talking about civil engineering problems and structure related issues and probably certain issues into asset management. Like what did it really took you to having this, I mean, broader views? Where did all start? Probably that would be a
Okay,
good
so
information for us as well.
okay, some of it is driven by us. So when as the university, like say even at Peradeniya, you're meeting your colleagues of electrical engineering colleagues in the tea room. So you can always start thinking about having a collaborative team. So that's one way. So when we are faced with the problem, if we recognize that we haven't got the expertise to help, we always think about approaching other academics to see, and we know what they're doing. So we look at it and say, so is there a possibility of a contribution? The other one is actually sometimes industry driven. So the Sydney Water Project, where we had collaboration across the 3 universities, they came to the 3 universities, or they came to the university sector, raising their problem. Okay, we have this asset management problem. We have an issue with our water pipes, and it's challenging, and it's we have billions of dollars buried in the ground, and we need to know what their condition is. When do we have to repair them? Because replacing one of these pipes is a huge cost, especially if it's in a built up area. So they in fact went around to the universities, and the obvious expertise there is the robotics expertise, for the sensing expertise. They actually came to us as, how do you sense stuff? And the other question is, when are they going? How are they failing? Which is the civil engineering question. So how is what's the size? What's the geometry? Or what are the stresses that will make them fail? And the other question is, when are they going to fail? That is the corrosion question. So if the wall thickness is 10 millimeters, what it will be in 5 years time? Is it going to go down to 3? And if it does go down to 3, the civil engineers are going to tell you whether it's going to fail. Or if you actually, sometimes in Sydney Water, what they do is that once they know that a pipe is weak, they look at pressure management, so that they try and reduce the pressure that goes into that pipe as a mitigating factor for reducing. Our challenge was, okay, how do we know what is in there? So once we know what is in there, the civil engineers can work out how is it going to break. Is it going to break, or what will happen? So what's the time? And the time frame comes from the corrosion models, which tells you that you are getting 1 millimeter corrosion every 10 years or something. So it depends on the soil corrosivity. So they go and measure the soil properties. Civil engineering guys use finite element analysis. We use some electromagnetic sensing. So I mean, our team actually has software engineers, electrical engineers, and mechanical engineers all together. But that's not essential in a university environment. You can get a team together in a place like Peradeniya to address a multidisciplinary problem. So that's a great question, but there is an answer.
Thank you very much, sir.
Thank you very much, sir. There may be more questions coming up. Dear attendees, I remind you, if you have any questions, please raise your hand, or otherwise type your questions in Q&A section. Okay, so I think that's it. So there are no more questions. So I would like to thank you, sir, for being with us here today. We sincerely appreciate the fact that you reserved your valuable time to be present with us here virtually, even though you're physically more than 5,000 miles away. So we are ever so grateful to you for gracing our occasion and sharing your projects and experiences in the field.
Thank you
Right
very much.
now,
Thank you for inviting.
you're
Thank you
welcome.
for inviting. Thank you, Asela, as well for inviting me.
Right now, it is time to move on to the most iconic moments of the day. We are excited to share the current research projects of the students of the E15 batch, the final years from the Department of Manufacturing and Industrial Engineering. From all the research and projects of the final year students of the department, few selected projects and research will be presented today by the students in a few minutes from now. And I would like to remind our audience, just like we did before, that after each and every presentation, the audience will have a chance to bring out their curiosity and ask questions. In order to ask questions, you can simply use the raise hand option in Zoom and speak up, or else you can use the Q&A button below to type in your questions. So the first project to be presented will be about generating efficient delivery routes by utilizing a heterogeneous fleet of vehicles, presented by Ms. S. Jagadishan and Mr. H.A.P. Hettiaranchi. Over to you.
Hi, I am Punsare Hettiaranchi. Name of our research taught to optimizing outbound logistic operation of a beverage company. This is a case study, and this research is conducted under the supervision of Mr. Dr. Asela Kulutunga and the Dr. Subeda Dharmapriya. Yeah. The research based on the Lion Brewery is a award-winning Sri Lankan brewery company. The attributes of the current distribution network of the companies: they have 18 distribution centers all around the country and 2,662 outlet number of retail outlets, and the distribution cost is 90% of our total overhead of cost of the company. The average utilization of the vehicle is 80%, and the company expects us to reduce the overall distribution cost, improve the vehicle utilization above 80%, and optimize the fleet with equal workloading. Out of 18 distribution centers, one in Beru has been considered for the research. Then they have 147 outlets, and the distinct weekly demand varies into 1 to 60, 600 units, and they have heterogeneous fleet with 4 trucks. In the literature review, there are many gaps between our current research and the literature. Let me give some brief into the literature. So the literature gap is the problem is the many distribution problem in the literature. Consider the homogeneous fleet of vehicles, and there are limited vehicle literature available for the heterogeneous fleet. And also primary objective is the minimizing the distribution cost. The limited study consider the workload balancing as an important requirement. So it's hard to find studies which consider both heterogeneous fleet and workload equal. But in the research, we have considered the both. Our aim was to optimize distribution operate in terms of distance and equal workload. And the objectives are develop mathematical models, solve the mathematical model using appropriate algorithm, identify different scenario to identify effectiveness of the alternative strategies, and they make recommendation to enhance distribution network performance. This is the methodology part. First we formulate the problem and mathematical, then develop a mathematical model, then solve the model using alternative algorithms, then they test different scenarios in the baseline model, and they provide recommendation. This is the overall approach we use to solve the problem. This is a problem formulation, and the here this is the representation of the distribution network of a distribution center, and they have a mathematical model. The mathematical model is main objective is to minimize the total travel distance under the constraint of vehicle capacity. Utilization of the vehicle capacity must be greater than 80%, and the time window, we have time window that out distribution of the single truck per trip must be less than 8 hours, which is working hours, and the travel mileage of a truck must be within the 30% of the range in the average mileage of a truck. That's considered the cloud equity. And the outlet demands must less than truck capacity, and the outlet is catered only one by one truck, and the truck is start and stop at the distribution center. So we have used both simulated annealing and genetic algorithm to solve this problem. Genetic algorithm. Genetic algorithm is an evolutionary algorithm inspired by Charles Darwin's theory of evolution, and it replicates the process of natural selection, where the fetus individual are selected through the reproduction to produce offspring of next generation. So this is the steps involved in implementing the meta-heuristic method. We define the algorithms to algorithm termination criteria. Then we are checking termination criteria is satisfied, or then generate the initial solution. Then apply local search strategies. We check whether the solution is improved. If yes, we check again the constraint has satisfied. If yes, then we store the answer and go back to the beginning. So the circle the steps might be changed or altered according to the meta-heuristic approach we are using. This is the step involving in the simulated annealing, as we suggested that in here this method is changed according to the meta-heuristic approach. This is the genetic algorithm approach we have used for the problem. Okay, this is the local search method, three local search method we use in genetic algorithm. First, we partially shuffle the solution and use generate the new population. Then second one is we interchange outlet portion inside the solution, as you can see in figure 10. And third one is we interchange the outlet portion between two solutions, as you can see that in figure 11. This is the result we used. We obtained using the both algorithm. As you can see that GA shows the better results as for the observation in here. But to make sure we ran this problem for 50 runs for both using both method to get better results. So as you can see that figure 12 represent the travel distance in 50 runs of simulated annealing, and the figure 2 is showing that genetic algorithm results for 50 runs. As the solution space of the current problem is bigger, the observation of one-time results may or may not be significantly valid to entire population. So we use the pairwise t-test to conduct results from 50 times of both algorithms. So this is the result. This is the result we obtained from the pairwise t-test. Since p-value is less than 0.05. We can conclude that GA shows the better results for 95 competence level. So we have defined the few scenarios to enhance our research. So scenario 0 is we use complete plate. In scenario 1, we exclude the smaller trucks, which is a 650cc truck from the fleet. And scenario 2, we exclude the 850, so on. In scenario 4, we use the largest capacity of the truck, largest capacity truck from the fleet, and use the other 3 to deliver the product. So this is the result we got from the genetic algorithm for the result. As you can see that we are looking at some observed data, but can we be sure this is accurate? As I said before, the solution space of the problem is very large, and the observation from one-time result may not be significantly valid. So one way ANOVA test is conducted using the result from 50 time from GA algorithm for each scenarios, and we are trying to find a better result. This is the results we got from first test. The null hypothesis is all means are equal, and the alternative hypothesis means not all means are equal. That means at least one is different. So since p-value is 0 less than 0.05, the scenarios are significantly different. So we can go to the next phase of the experiment. So as the plot suggests, you can see that scenario 1 is a better option for 95% of confidence level. So this is the model summary. The model shows that the model explains the behavior of the population by 57% to 9, and the rest of the all scenarios are explained by the rest of the percentage. As the conclusion part, the genetic algorithm is compared to better option to solve the problem. The total travel distance of the current system is 1,852 kilometers, and the average utilization is 82. In scenario 0, the baseline model, we 10.25% distance is reduced, and the average utilization is 96%. And scenario 1, we obtain 12.95% distance reduction, and the average utilization above 96%. So scenario 1 is a better option compared to the other scenario, as the test suggests that the removing lowest capacity vehicle reduces the frequency of going back to your house for the refill. So that obviously reduces the distance, and the opposite mechanism where the conclusion can be observed in scenario 4, as the scenario 4 shows here is the highest distance. They show the highest distance in the problem. So as the further improvement, we can organize and optimize the current code according to the programming technique, and we can train neural network system to analyze the future trends such as demands and traffic. There's the support the decision to reduce the fleet and outsourcing when needed, and the connect with Google Map API to get the real-time traffic data and the speed data, such things. So challenges and key learning, the achieving objectives. The challenges are the absolute programming knowledge and the adaptation between the theories and practical problem, and the hardware challenges considering the processing time. The key learning was the meta-heuristic method and its application, and the Python programming and VRP and its variants. This is the reference we use in the we use this all the research. So thank you very much.
Ladies and gentlemen, that was Mr. H.A.P. Hettiarachchi on generating efficient delivery routes by utilizing a heterogeneous fleet of vehicles. So, dear attendees, if you have any questions to direct toward Mr. Hettiarachchi, just as we did before, just please raise your hand or speak up or type in your questions in the Q&A session. We have a question coming up.
I just have a very simple question. It is not technical. I don't know what HAP stands for, so I would call you Hettiarachchi. So what in your learnings you listed down or knowledge or technical wise what you learned is there anything that you learned beyond your technical knowledge through this project, through your research?
Yes, ma'am. Can you hear me?
Yes, we can hear you.
Can you hear me?
Yes, we can hear you, but there's a small delay.
Yeah. The technical knowledge I learn is mainly the programming knowledge. So when I didn't know the Python and the other. I used the Python programming for the problem. I had to build it from the scratch. The algorithm. And the important thing is before the research, I didn't know about the Python. So anything about the Python, so I had to learn it from the beginning. So that's the main technical thing I learned.
Sorry, Hettiarach, I think my question was not clear. That you had, of course, listed as your learnings. My question was, what are the non-technical things you learned through this research?
It's about the theoretical knowledge about the meta heuristic and other variants, and the how to adapt from the theories to the practical scenarios. So the thing was we couldn't use exact safety algorithm for the problem. So we have to make some alterations and to reduce the technical terms, technical difficulties such as process time and the programming to make the programming easier. So we have to make some adaptation and get accurate results. So we have to use some adaptation. We have to adapt the algorithms to practical scenarios. So that was one of the main things I learned from.
Thank you. It's a very interesting research. Thank you very much, and well done.
Thank you for that interesting question. And we have another question coming up in the Q&A session. So, Mr. Hettiarach, let me narrate you the question as it is. Did you try presenting this to the industry, and how was your experience?
Yeah, I think I didn't have that chance to present this to the industry, but I did from this department research, so I presented to the department only. I didn't have a chance to present this to the industry yet.
Thank
so
you.
I think this we develop more than this to present to the industry. So I have several improvement ideas. So I think I have to improve more into the industry, and I think still this can be implemented. This can be presented, but to implement to get better result, I have to improve more.
Thank you. Are there any more questions?
I also noted that in the further improvement part.
Let's wait a few more seconds to check if there are any more questions.
Yeah, I have a question here. Can you all hear me?
Yes, we can.
Now, Hettiarach, in the project that your outcome is basically to optimize the distance travel. Now, how does it, when it comes to industry, yeah, distance has a relevance, plus companies are more interested on the cost. So
yes.
How does your optimization of or the reduction of travel distance correlate to the overall cost reduction? For an example, now you use heterogeneous fleet, and smallest vehicles has a cost per kilo or cost per I would say selling price is higher than the larger vehicles. So how does the cost optimization could correlate with your findings, and has it been discussed with the Lion Brewery?
The first thing is still didn't discuss with the land brewery. The thing is, we have to when we have to consider the cost, we have to consider the several factors such as fuel, employees, and the maintenance cost, and the other things. As you said that the trucks cost. So that's why we did the scenario analysis to find out if we remove some vehicles, change the plate. If we change the plate size, can we get the better results for in distance? Basically, we focus on distance. So can we obtain the better results from that focus? So we have got some better results in there. I said in scenario mode. So we know that we can use this algorithm to identify that can we go for the outsourcing. Can we go for outsourcing rather than using own fleet, rather than maintaining it? So we have to do the cost analysis also. So I think it is the next step, the cost analysis, considering the outsourcing and owning own plant.
It's in fact, Punsar, it's a very interesting project, I would say, and it shows how does the we call hardcore engineering is different from the rest of the engineering. You see, you have looked at the supply chain management and using in a very interesting in a technical mathematical model resolving a problem. I think that's a fantastic project, and my suggestion is you should carry it forward. You should do the further studies, refining it, and present to the industry and try to implement it. I mean, that is what the key is. So don't stop this project at this point. Take it to the industry, talk to the relevant in the Lion Brewery or some other, maybe other companies like Unilever's who are interested, and try to implement it. Then that will basically takes you to the next level. Yeah.
Thank you very much.
Thank you very much, Mr. Hettiarachchi, and thanks for all those interesting questions as well, because those questions suddenly made our event even more alive. Now it's time to move on to our next presentation, that is on the simulation of the end milling operation for force analysis for aluminum by Mr. D. Hirumuthugoda and Mr. P.M.A.P. Kumar. Over to you.
Hello everyone, I am Asanka Padkumar. My project partner is Dinuka Hirumuthugoda. This is our research presentation for the Symposium, Simulation of End Milling Operation for Force Analysis of Aluminium, proposed under this, which is done under the supervision of Dr. Rishika Ekanayake. Milling operation is a famous, versatile, subtractive manufacturing operation. End milling is the one type end milling operation. End milling widely used many manufacturing industries, automobile industries, aeroplane industries, mold die manufacturing industries, like that. When we focus on cutting action of end milling, it has intermittent cutting action. It doesn't appear continuous cutting action like lathe. Due to this intermittent cutting action, it produces fluctuating cutting process during milling, like as on this figure. Consequently, it appears vibration in end milling, and it is a big problem for us in end milling operation. So it is very important to analyze this cutting process to minimize this vibration phenomena in milling. From the literature studies, we have found out that finite element modeling method has been mostly used for force analysis in machining, including milling operation also. But most of studies have been done only for few tool revolution to take cutting process. Most studies analyze cutting process 1 or 2 chip separation step, but it is not enough to reach some conclusion for whole milling operation. So we have identified this research gap, and we have done our research for sufficient tool revolution. Actually, this project is about basically develop 3D finite element model for the end milling operation of aluminum, and then predicting cutting process using simulation in Abacus software instead of getting cutting process by doing some experiment. To build the 3D finite element model for end milling operation, it is required some input parameters. First one, we have to build the CAD model that is virtual workpiece and end mill, and also required simulation parameters, boundary conditions, interaction properties, material parameters to build 3D finite element model. After the setting up all the parameters, we can finally get 3D finite element model. After setting up suitable cutting parameters, we can run the simulation. Then we take required data by changing the cutting parameters. Several simulation run can be run. This project we have get required cutting process on the tool centroid. After the analysis of process, we have verified the result with available literature in similar literature. These are the key specifications in the simulation. The end mill cutter is with 4 flute, 10 mm diameter. Material is high speed steel. The workpiece type is aluminum 61 T6, and it is rectangular block with dimension of 25 by 30 by 10 mm. And we have used SolidWorks software for build CAD model, Abacus software for simulate the end milling operation, and GNU plot for plotting graphs. The most important requirement for the simulation is selecting proper material parameters for the workpiece. The Johnson-Cook material model is a material model which is famous for modeling machining operation. So we use material parameters of aluminum 6061 T6 from this journal article, which is done by Sohal Akram and other researchers. This is a snapshot of it. This figure shows the 3D finite element model built under the some assumption. Those are material homogeneous, and we assume that this is a dry constant end milling operation. This figure shows the mesh structure of workpiece and tool, and detail of it are in the tables. I would like to show you the cutting action of end milling operation. End milling operation in a simulation. Let's see us. Next, these set of figures show you how chips form in the simulation. It's like actual chip formation in end milling. Let's move to the result section of the project. The coordinate system we use in the simulation is shown in the upper corner figure. The spindle axis is along y-axis and feed rate is along z-axis. Here workpiece is stable and tool is feed towards the workpiece. For all the simulation, depth of cut is 1 mm, and we change the feed rate and spindle speed and obtain cutting process on tool. This graph is variation of cutting process on tool centroid. For spindle speed 1500 rpm and feed rate is 10 mm per second. Likewise, this graph is for spindle speed 2400 rpm and feed rate is 20 millimeter per second. We analyzed the cutting parameters, how its effect on cutting process. So this graph is illustrate variation of resultant process on tool for different spindle speeds while keeping feed rate and depth of cut is constant. You can see here red color one vary on lower pace and purple color one vary on upper pace. That means generating cutting process are reduced with increased spindle speed. So likewise this graph about feed rate, how its effects on the cutting process. Here you can see in couple of figure, cutting process are rapidly increase with the increase of feed rate, while other parameters are in constant. Finally, we have come up with some conclusion with the simulation of end milling operation for process analysis. We have successfully simulated the end milling operation with chip formation by 3D finite element method. Cutting process are slightly reduced with increased spindle speed, but cutting process significantly increased with increased feed rate. From the several simulation run, we observed that finite element model can be used for predicting cutting process instead of doing several experiments. So this method is economically advantageous. We think this project is very useful in manufacturing industry. This work form a foundation for some other projects. One is that optimization of end milling operation with achieving some objective of getting high material removal rate, best surface quality, or getting minimum production cost, like that. Although our project have done with linear end milling operation, this work can continue for real end milling operation along with non-linear path also. This is about our final year research work. These are the main references used in our work.
Ladies and gentlemen, that was the project by Mr. Diluka Hirumathugoda and Asanka Padmakumar. Just as before, if you have any questions for them, please raise hand or type the question in the Q&A session. We have a question coming up from Professor Gamini Dissanayake. Professor.
That's a very, very interesting piece of work. So it's very, very impressive analysis you all have done. I saw at the very beginning you had a graph showing experimental results and simulation. So did you actually make a comparison with your data? Did you actually measure the forces and try to compare it with what you're predicting?
Actually, not, sir. Due to the COVID situation, we can you hear me, sir?
Yes,
I can. Yeah.
Thank you. Due to the COVID situation, we couldn't use the lab facilities, and
okay. Yeah.
We only use simulation platform for analyze the cutting process.
Okay, no, that's understood, because I think your very first slide shows that the simulation, at least literature says that the simulation and experiment results agree. So yeah, so if you have the opportunity, you can test it. But I understand this is a challenging scenario for any lab-based work, isn't it? But it's very good work. Thank you. It's very nice.
Thank you. Thank you.
Yeah, attendees, if there are any more questions you want to direct, please feel free. Looks like we don't have any more questions for this project. So thank you, Mr. Padmakumar and Mr. Hirumathugoda. And moving on to our next presentation. The next presentation is on designing an electronic differential for an electric vehicle for traction application by Mr. BKPL Maduranga and Mr. WWGA Jayarakum. Over to you.
Hello and good morning everyone. I am Praneeth and my project partner is Gihan. Our research is on designing an electronic differential for an electric vehicle for traction application. We have done our research under Dr. Dinesh Koduthuwakku and Dr. Achala Pallikethara. So at the present, usage of electric vehicles are increasing rapidly. The main concern about the EVs are their range. So companies continuously trying to increase the range of the EVs without increasing its mass. To obtain the real advantage of the electric motors like quick torque response, motors should be mounted or coupled directly into the wheels. So this is the small demonstration of the problem. You watch this before I continue. So what you have saw in previous video is wheels slipping due to the lack of friction of the surface. So the friction is not enough to move the vehicle. So where in the terrain is a point which all vehicles struggles to operate smoothly. Torque requirements for motors differ with the terrain conditions. Wheel slipping takes place when there is no sufficient traction. Also mechanical differentials is which used in current vehicles are heavy and large. We set our scope is to drive autonomous robot smoothly on a predefined path in a rough terrain, and our aim is to reduce deviation from the predefined path when robot moves on a rough terrain and recover from a situation where the robot is deviating from the intended path because traction of one drive wheel is not enough to move the robot. So objective is to design an implementation of disturbance observer based electronic differential for the electric vehicle or the robot. So this is the final look of our mobile robot. It has 2 drive wheels and 2 caster wheels to support the structure, and encoder is directly coupled to each drive wheel to track the motion of the robot. And also there are 2 current sensors in the robot to measure the current flow for each motor. So we have done this research only using encoder readings and current sensor readings, no any other sensors. So let's discuss the methodology. So this is the equation we use for calculate the disturbance torque. Nominal inertia and nominal motor constant values are acquired from the motor datasheet. Angular acceleration was measured using encoder. Reference current is the current sensor readings. So this is the block diagram for our disturbance observer. So this is the definition for the traction force. Basically it is the shear force generated at the contact point of the wheel and the ground. So this is the equation we use for calculate the shear force. So in here we assume that disturbance torque is equal to traction force multiplied by radius of the wheel by considering few assumptions. So DOP estimate the torque due to the traction force. So it is a form of differential which used to give different torque commands to different drive wheels and of the electric vehicle. If we consider one wheel slipping situation, we can use the estimated disturbance torque from DOB to move the stationary wheel. This is the complete operation of the electric differential in a block diagram form. So I am not going to explain it as I already explained it in the operations briefly. So as the equipment and software other than I described earlier, Raspberry Pi 4 Model B was used as the main computer and two DC motors were used for wheels. So this is the angle track we prepared for the testing purpose to test the functionality in different terrain angles. So next we have to discuss about the results and discussion. So I will invite my project partner Gihan to carry out the rest of the presentation. So thank you. It is over to Gihan.
Thank you, Pranit. I am Gihan and I will discuss about the results. So we created the setup using an incline track. As you can see, we created the slippery track for the right wheel using a smooth surface and some grease, and the left wheel was on a rough surface. So as we discussed earlier, if we consider a situation where one wheel is slipping on the surface due to lack of friction and the other wheel is stationary and the vehicle doesn't move, this video demonstrates that situation. As you can see, the vehicle can move. So what we have to do is we have to move the stationary wheel in order to move the vehicle simply. So when the right wheel is slipping, we gave the same command to the left wheel in order to move the robot, and this is what happened. As you can see, the robot totally lose control and deviate from the path. So when we use the estimated disturbance value from the right wheel to move the left wheel, according to our electronic differential concept, as we had discussed earlier, this is the result we get. So when we saw the right wheel is slipping and when the is on, as you can see, the robot obtains the stable movement to recover from that situation. So this is how the velocity commands are given when the ED is implemented with the DOB. As you can see, while the right wheel is spinning, the DOB estimates the disturbance and the controller uses that to give a torque command to the left wheel controller. And the left wheel receives a velocity command according to that disturbance torque. And that's why the velocity commands are different for each wheel. Next, we try to get the same result for different inclination of them, but we couldn't test for wider ranges because if it's too steep, the other wheel start to slip, and if it's too low, the right wheel won't slip. And we couldn't go for higher speed since the battery voltage was not enough for higher torques. So we tested for 3 small angles, and the results were acceptable. So this is some of the challenges and difficulties we faced. So we assume that internal disturbances can be neglected, but when we are using old motors and gearheads, it can reduce the accuracy of the disturbance estimation because if the internal disturbances and the nominal motor constant and actual motor constant is not the same, and the battery voltages was not enough to go for higher velocities and torques. And then we learned about these things. Some of the things we learned about this project, differential function of the vehicles and advantages of electronic differential and traction control systems. So as for further improvements, we can try to experimentally find the values of motor constant and inertia values of the motor, so it can increase the accuracy of the DOB. And most importantly, we can integrate this concept with existing control system like traction control systems, because traction control systems determine slipping condition using sensors, and the control torques until the desired torques are applied. In this ED model, we can estimate the required torque. So integrating these two systems, we think we can obtain more robust and responsive systems. And these are the references we used. And this is the end of our presentation. And thank you.
Dear attendees, that was the result of the hard work by Mr. Praneeth Lakshan Maduranga and by Mr. Gihan Akilajagath. Just as before, if you have any questions, please feel free to raise hand and speak up or type your questions in the Q&A section. We have a question.
Kulani, I have a question from the project team. This is again a very interesting project that I've seen. I wanted to know that now you have kind of designed a new method, right? So how did you find this was new? Did you look at the existing? Yes, I saw some references which are papers. For example, how would, I think Volvo has a fully electric SUV. It is not off-road, but it's still fully electric SUV. So that also must be having some system, right? Did you check what is the difference that you have and how they do this? Or did you look at any patterns, IP out there that to find out whether what you are doing is different? How did you come up with this new method that others do not have, and how do you ensure this is a new method?
Actually, first we explore about the literature about researchers about electronic differential. Usually, what they are trying to do is they use some. Usually, they experimented with the steering vehicle. We don't have steering, but they use models like Ackermann-Jordan model. Like they can estimate the torques required to go in a curved path or straight path, something like that. They can change the handling or steering like that. They can change the handling according to that model, because that model can calculate the required torque to each wheels. And when it comes to traction control, we also refer to the research papers. They usually, what they are doing is they use a modified model like that, and they rely on sensors to detect slipping. And when it comes to automobile industry, we check with some resources like YouTube, what they are using in that technologies like traction control systems and ABS and crawling control system. They also try to do is they use speed sensors to detect any. They usually those exact same models. They may be using same exact models for try to determine the torques. But when it comes to sleeping conditions, they usually talk. What they are doing is they rely on sensors. What we are doing is in this even this robot, we don't have any sensors like that. We only have encoders and current sensors. So what we are doing is instead detecting those sleeping conditions, we estimate, we use that the disturbance observer concept. What we are doing is we detect the disturbance occur from the external and internal systems. We estimate those disturbances using that model. So when we use that torque disturbances, we can obtain more robust control systems to our normal control system when we move the robot, because then they represent condition we represented. There's a condition that the wheel is the traction not enough to move the robot. So we estimate that traction force in that wheel, and we transfer it to the other wheel where there is enough traction to move the robot. So So when we do that, as you can saw earlier, we can move the robot because that force is enough to move that slippery condition. And when it comes to normally in automobile industry, when they are turn on the control system, traction control systems like that, they usually measure the speed and wheel speeds, and they trying to balance the torque according to that sensor readings. So we can say, other than relying on the sensors, we can say this is a more reliable system because we rely on current readings, because current differences are more responsive to those disturbances of the wheels. I think that answers the question.
Understood, Gihan. So if this is a unique way, Gihan, have you looked at applying for a patent on this? Applying for any intellectual property?
Actually, we are trying to publish a research paper. We didn't have much time to do a lot of work. We are actually planning on doing this onward.
Right. Good. Thank you.
Thank you.
Let's see if there are any more questions coming up. Looks like there are no more questions. I'd like to encourage the attendees, if you have any questions, please feel free to ask. Then we will move on to our next presentation by Mr. Chiran Kodipili and by Mr. Rajiv Karunanayake on a study on how organizations approach to synergize Lean and Industry 4.0. Over to you.
Good morning, everyone. I am Rajiv Karunanayake, and together with my colleague Chiran Kodipili, we will present our final year research on how organizations approach to synergize Lean and Industry 4.0. Over the last few decades, Lean has spread over most manufacturing industries as a best practice for minimizing waste, increasing efficiency, and maximizing resource usage. However, during the recent past, Industry 4.0 has made a disruptive transition, taking over existing best practices of manufacturing industry as digitized and networked production systems. Now, this has sparked concern as to how these changes would affect the well-established Lean systems. Therefore, through this research, we explore how Lean would transition into the new digital era in the apparel industry. Our aim is to understand the organization's approach to Lean manufacturing and Industry 4.0 and to formulate a synergized framework. And below are the objectives followed to achieve the aim. We further discuss the key elements of synergies and disparities, and through this, we tend to give a deep understanding on how the two concepts can be leveraged in a mutually beneficial manner, and also the potential disagreements to watch out for. In selecting the research approach, an abductive approach was found to be the most effective way ahead due to the availability of various means of information through which conclusions could be derived. Therefore, we started off through a thorough literature review on Lean and Industry 4.0. Following that, we developed a comparable relationship matrix, and then this matrix was followed by a data collection process, which were threefold to achieve triangulation. This will be further discussed in future. And then the analysis was done in terms of response analysis and a maturity analysis, which resulted in the refined relationship matrix, which is the heart of our research, which will also be discussed further. Let's start by understanding the selection of frameworks. The initial screening was done of 47 Industry 4.0 papers. And after skimming through these papers, we shortlisted 6 papers according to a shortlisting criteria, as you can see. These 6 shortlisted papers were further shortlisted by focusing on areas which related to both Lean and Industry 4.0. And finally, by discussion, we selected the Industry 4.0 framework of Bagire and Rathore. In terms of lean, we referred the Toyota Way book by Jeffrey Leica and extracted the executive summary of 14 principles to decide on the lean framework. Now that we have two frameworks for lean and Industry 4.0, we were able to develop a comparable relationship matrix. So as you can see, on the columns are the Industry 4.2 assessment items, which adds up to 38, grouped into 7 areas. On the rows, we see the lean assessment items, which adds up to 14, grouped into 5 areas. In total, we will be mapping 532 relationships. So basically, we contrast and compare lean assessment items to Industry 4.0 assessment items under a grading criteria ranging from 2, which is highly supportive, to -2, which is highly disruptive, and excess for relationships which are neither supportive nor disruptive. Now let's try to understand the data collection process. The first data collection process were interviews and focus group discussions. Since we had comparatively less industry experience, through interviews and discussions, we were able to understand the reality in the industry and other practical challenges. This provided us with a solid background knowledge to initiate the individual grading. Hence, secondly, we individually mapped the relationships under the criteria explained before. Having done so, we collectively remapped all 532 relationships to arrive at a consensus for each to weigh in different perspectives as well as to eliminate biases. However, there were a few relationships for which a consensus could not be reached. Hence, a survey was developed to gain further insight. Which brings us to the final data collection method, which is a survey. 2 questionnaires were developed, one which was shared with experienced employees of a leading apparel manufacturing company in Sri Lanka, and for the second, it was shared in online forums relating to Lean, Industry 4.0, and production planning. And now to discuss the response analysis, maturity analysis, and the refined relationship matrix, over to you, Chiran.
Let's look at response analysis. Firstly, responses were converted into a 5-point Likert scale. Statistical analysis suggested that 2 datasets can be combined. You might have the question of the reason behind collecting 2 datasets and combining it after. Well, it ensures that we have data in hand to extend the research in different aspects such as education, country, project phase, or industry. Non-parametric statistics was used to find a good indicator to represent respondent data. Let's move on to the maturity analysis. Literature review and interviews suggested that Industry 4.0 and lean maturity could have a positive impact on synergies, which was confirmed with 86% of the respondents agreeing that maturity does have an effect. Questions related to lean and Industry 4.0 maturity were grouped and only relevant elements were considered to assess the relationship. Spearman's coefficient was calculated to quantify the effect or strength of the relationship. Final stop is the refined relationship matrix. In shades of green are the different levels of synergies, and yellow-red shows different levels of disparities. Blue shows neutral relationships. First result of the research was a synergy framework, which can be used when a lean implemented company adopts Industry 4.0. If an organization were to implement Industry 4.0, they can refer this framework to identify potential smooth and easy implementations or Industry 4.0 elements with disruptions, which will have to be implemented with caution unless the organization decides to skip that implementation altogether or maybe delay it. It was identified that survey respondents had positive regard towards the mutual support of Industry 4.0 and lean. Maturity analysis provides an understanding on how synergies are based on lean maturity and Industry 4.0 maturity. 6 correlations were found using strong positive relationships with Industry 4.0 maturity. Let me take an example and show our results. Initial investigations led to identify IoT has both supportive and disruptive behavior with lean. Once the relationship matrix was refined after the survey, results showed that respondents believe that there is a moderately supportive nature with lean. So respondents have disregarded the disruptions in favor of synergies provided by IoT as an Industry 4.0 tool. Once the maturity analysis was conducted, rationale behind the respondents' opinion was understood. In the beginning, or when IoT is at a primitive stage, it might be perceived as an untested technology, which will disrupt lean practices. However, if comprehensive IoT tools were implemented or gradually evolved to a comprehensive IoT platform, those disruptions will convert to pure synergies. Let me now discuss conclusions and challenges. We use 14 principles of lean and 36 principles of Industry 4.0 from the GRES model to break down synergies. Even then, assessing synergy was a hard task. Gap between theoretical and practical scenario was understood with interviews and survey done with industry personnel whom had experience in both lean and Industry 4.0. Developed synergy framework can be used as a guideline when implementing Industry 4.0 ideology or tools into a lean environment. Or it can be used to tweak lean practices in an environment to facilitate a smooth Industry 4.0 journey. Maturity analysis shows that which elements will disrupt at the initiation but becomes very supportive to lean when matures. End-to-end digitization, IoT, digital supply integration, and simulation were such tools. Thank you very much, and we'll be happy to answer any question.
Ladies and gentlemen, that was Mr. Rajiv Karunanayake and Mr. Chiran Kodipili on a study on how organizations approach to synergize lean and Industry 4.0. So, if you have any questions to direct to them, please feel free to raise hand and ask your questions or type in the questions in the Q&A section. We have a question coming up.
Yes.
Yes. I think we had a question, but
Yeah. Can you hear me?
Yes, we can.
Okay, sorry. My question goes to Rajiv and Chiran.
There he is, sir. You can go on.
Very good job, Rajiv. Sri Lankan context, or have you collect any international data?
Mainly, sir, it was in the Sri Lankan context. However, when we were to publish a survey on the internet, we got few comments from the international community as well. However, if we were to consider the balance between Sri Lankan inputs and international inputs, of course, around 80-90% of the respondents was from Sri Lanka.
We have another question coming from the Q&A.
In that context, which concept is more Sri Lankan?
To answer that, sir, this is my personal opinion. I feel that when lean came to Sri Lanka, So your connection seems to be a bit unstable.
I'll just
I think Mr. Asoka Bandara has.
yeah. Can you hear me?
Yes, we can hear you, sir. And you're visible.
Okay. Okay, I will continue on asking another question. So, what do you more suggesting on this project for Sri Lankan industry to advance lean or the industry? What is
So I think
relevance to our industry?
yes. So I hope I got you. I understood your question right. Correct me if I'm wrong. Your question was, what is more suitable to the Sri Lankan context? Is it lean or industry 4.0? Am I right?
Yeah, sure.
Yes, sir. Yes. So in that context, what we understood through our research is that we always feel like, industry 4.0 is a very disruptive technology. It's a very disruptive concept that would go against lean concepts. But through our research, what we understood is that it is actually not so. We can implement industry 4.0 to be an enabler of lean and TPS, but there's a small catch here. We have found that most industries, even in research papers, we found that most industries have blindly implemented industry 4.0 just to jump into the bandwagon of being tech savvy. However, if we really if we implement industry 4.0 and all these digital technologies to where opportunity exists, basically we have to implement industry 4.0 and digitization. We have to pull them into where opportunities exist, as opposed to pushing technology. So if we can do that, we really feel like we've realized that there are so many opportunities where lean and industry 4.0 can be mutually enabling, the areas where they can mutually support each other. So it doesn't matter whether it's in Sri Lanka or in another country, there are so many areas, of course, different levels. If we can implement these properly with proper understanding where opportunity exists, definitely together a cohesion of both would be the way ahead.
Okay, thank you, Mr. Raju. Thank you very much.
Sure.
We have a question from Mr. Thilan Samarawickrama.
Yeah, my question is for Rajiv and Chiran. Now, first thing, why did you think that a comparison between Industry 4.0 and Lean? Because if you look at these concepts, Industry 4.0 is an evolution of Industry 1.0, 2.0, 3.0, and 4.0. So what we would see is, now if you look at those are evolutions on, it depends on the I would say the development of technology. I would say a series of technologies starting from the mechanical, came into the electronics, then came to ICT, and then you got the AI. So like an AI thing is now at 4.0 level. But if you look at the lean is a philosophy, right? So this lean philosophy could be applied from industry 1.0 to 4.0, and it could be applied to industry 10.0, which would come in future. So we would see in industry, this lean is a concept and it's a philosophy, and these are all the industry evolution numbers it's kind of verticals, which supports those concepts. So for an example, simple thing, the lean, say it's okay. In simple terms, in layman's term, we say lean is always looking at about optimization or reduction of waste. Now, what does the 4.0 does? It basically enables it. It basically works on that concept and to enable it. So that's what we think now. I mean, if you look at the research, what is the key takeout here? Do you see any difference, a significant, I would say, disagreement between lean and the 4.0? Do you see anything like that?
We found, sir, we found several aspects in that regard, especially when we come to say AI and the big data, and based on that predictive models and the decision making, there comes a situation where computer or the data generated information somewhat conflicts with what the people in the shop floor and say mid-level managers suggest, so that say that how can I put this way, so that dilemma between human made decisions and computed decisions are the key aspect that we have understood from this research. So the best example I can bring is say emulation. So with Industry 4.0 enables simulation, we can ensure that with with the support of lean, we can ensure that production lines are well balanced and they are somewhat robust. But when it comes to say some data generated from a probabilistic model or a predictive model like say emulation, but that doesn't quantify the unseen aspects or some say some unique aspects of manufacturing environment. So in that sense, yes, the decision making between some automated or in Industry 4.0 enabled technique and people driven culture of lean, so that conflict we have understood through this research. And Rajiv, do you want to add something as well?
Yes. So, and also in addition to that, a practical scenario that we realized during our training was in some of the organizations that we worked at, the lean principles and world-class manufacturing, TPS, these were driven by a separate department. And the innovation aspect of it, the innovations and digitization projects, they were driven by a separate department. So we actually saw clashes between these for reasons that Chiran just mentioned, of lean being very much people-centric. And also, according to Jeffrey Liker, he says that we have to go slow and be very cautious in adapting new technology. So we found a lot of disparities, and as we spoke to people as well, we found that there were certain areas where these two departments did not agree with. So we just wanted to find the best way ahead where we can marry these two concepts and understand which areas could be leveraged and be supportive and which areas that could be disruptive, and how to really how to face such disruptions. So I hope we answered your question.
Yeah. Now, giving a small another feedback to you, it's, you say the two different departments handle it. The reason, it comes to the way the change management comes. The one department uses the lean manufacturing is done by day-to-day manufacturing, which they do the day-to-day work, and there's another department who runs the innovation. So always, when you're trying to get the innovation into the day-to-day practice, always there's a clash. Either it's a lean lean or Industry 4.0, even a simple ERP implementation, it would happen. So it's where the change management happens. And you say there's a conflict between the big data and the shop floor data. So when you say the big data, now the big data always has to refine, because big data gives you a bigger picture of the industry, which it may not exactly relevant to you. So that is where the management knowledge comes in. See, so top management has to get involved. They have to filter the big data, and you have to extract what is relevant to your industry and to your workplace, and then implement it. So if you try to do it as a blindly, yes, obviously it's going to collapse. It's not relevant to, it's not specific to this. It's to any change that could happen in industry. Yeah, and it's a fantastic project, and you have done quite a lot analysis, and it's something it's pretty interesting and pretty new. I think that's the very first thing which I asked you. Why did you all want to do something like this? And it's good, and it gives you a good insight to even your colleagues and even the fellow undergrads. Right. Thank you very much.
Thanks for insight, sir. Thanks.
Thank you, sir.
Raising hand to ask a question, we have Ms. Sithila Dassanayake. Please go on.
Thank you. Thank you, Kulani. So Chiran and Rajiv, I'm impressed with the knowledge you have gathered through this. So from your answers, we see, this is not exactly a question, this is mostly a comment. You have got a lot of knowledge through it, and basically you know your stuff here. So that's the first thing that I saw, and that's really good. And it is not about whether this is this or that. I agree with Thilan that lean is a philosophy. However, Industry 4.0 would have so many tools. It is not only an enabler. And Rajiv, you are very right. You might have heard of this light out factories, where some went into this Industry 4.0. They wanted everything automated, everything through systems, not a single human being. There's no lights in the factory one. So this failed. They didn't work, right? So they might not have worked for several reasons. However, that you are right. You have to do that. You said in your conclusion, it is you have to study this, and you have to see where this particular company, if you want to apply this, if you want to jump into Industry 4.0 in lean journey, where you are, you have to identify. For example, I'm coming from a organization where lean is implemented years ago, and still we are not there 100%. And our plants are not at very different stages of the journey. So you are very right. The interpretation is very important. My question to you is this. Maybe it is to your academic staff as well. These projects, are you planning to take them forward if there's a request from the industry? Or how does it work? You guys are now done with the research. You publish your paper and you go away and that's it? Or how does this going to help the industry is my question.
Sithila, from our end department side, basically from time to time we get some industry projects, like even for the brewery, it was a 2 years project. One group already done one simulation part, and this time they have done some analytical work. So likewise for these projects, usually we continue, and sometimes it will be ended up with the industry. Sometimes it's kind of an analysis, academic analysis. So both options there, and depend on the interest, this will be continued up to the implementation as well. Actually, this was supervised by Dr. Prasanna. Prasanna, you also can come in.
Thanks. Well, yes, of course, we are looking forward to, in fact, we realize there is such need in the industry anyways. And this is how all this initiated. And of course, we are looking forward to work in collaboration with the industry. Probably this can be one of the research arms in the department, because right now we are seeing some kind of a transition happening, and of course, like we have a cluster which is called factories of the future. So this research will mostly fall into that particular cluster. So in that journey, we are also interested in how to build upon the existing like philosophies and the ways of thinking. Of course, we are looking forward to continue in the same lines.
Prasanna, just to caution you, there would be two key problems that I see when you go to the industry. Number one, as Thilan rightly said, that day-to-day operation optimizers are really scared to do leapfrog stuff, to put something new, because they are comfortable in their optimized ways. Even lean tells always standardize, optimize, then only move to the next stage. They don't talk about leapfrog, total different technologies bringing in and such. So that thought might not be the right interpretation of lean philosophy. However, that might be a roadblock, a key barrier to you, number one. Number two, like lean, you might not be able to do Industry 4.0, like plant by plant, because your IoTs, your AIs, you might need data across and such. but you might say, I want data across, but the implementation I might do only in one place, show it through your AI, you are going to refine it, and then you will roll out later. So these are the two key things that I see from my point of view that industry might pose on you. Thank you.
Thanks a lot, Sithila. Yeah, we'll definitely keep that in mind. Thank you very much.
Actually, we have a question in the Q&A section from Dr. Prasanna himself. I think I will narrate it. The question is, what was your most surprising finding, and if what are they? There was any.
So if I answer that question, Chiran, you also can add anything to this. For me personally, it was the difference between so as I said, we had 3 phases of data collection. The first phase was the insight that we got through interviews within the industry personnel, and then the individual grading. And finally, we did a survey, right? So the difference and the disparities between the results that we got in terms of synergies and disparities, and the results after the analysis were, for some cases, they were very different. And as Chiran rightly described during the presentation, one of the reasons was like industries getting used to and adapting to these new technical concepts, and finding ways of getting over the disruptions. So the change in the perception that we had and the actual scenario, the reality in the industry. So these differences were quite interesting, and how we interpreted these, and together with Dr. Prasanna and the other insights that we got, these were very interesting things that I personally thought were very striking. Chiran, anything to add?
I'll share a key, the discussion during chat strategy. So what I understood was that lean was not, say, implemented or developed or overnight, and it was somewhat developed with the Japanese culture and their people, their techniques, and also when we come to Sri Lanka, Bangladesh, or India, when we were to implement lean techniques to Sri Lanka and other countries, we have to make sure that the core idea behind that implementation, or the true motive behind that implementation, it should be there. So we felt that with both Industry 4.0 and lean, it was some sort of a disparity between the actual requirement and the tools or techniques implemented.
I think that is it for the questions. What an interesting session we are having right now, and we can see the momentum building up. Just we are only halfway through the presenting the work of our final year students. So please wait, we have more presentations coming up your way. Before that, please keep your attention on the screen as we move on to our virtual poster session. The summaries of all the projects and researches done by our final years are displayed on our website as virtual posters. You can visit the link which will be visible in our chat in a few moments to reach those posters. And here is a small video on how to do so. After the video, we will be having a small break of 10 minutes. I kindly request you to examine the posters and maybe take a little time to relax during this time and maybe stretch a little bit. And Industrio 2021 will be back online in 10 minutes at just on 11:30 to be back with you. everyone. Welcome again to Industrio 2021, a project and research symposium organized by the Manufacturing Engineering Association of the University of Peradeniya. Without further delay, let me have the pleasure and the honor of cordially inviting our chief guest for the day to address this virtual gathering, Engineer Jagath Jayasundara. Engineer Jagath Jayasundara is currently the Chief Executive Officer of Advanced Electricals PLC. He counts over 14 years of industry leadership experience and has acted in various capacities during his long-standing career at Regnis Lanka PLC. Mr. Jagath Jayasundara holds a BSc Engineering degree specialized in production engineering from the University of Peradeniya, once again a proud alumnus of our own department. He holds a Master of Business Administration from the Postgraduate Institute of Management, University of Sri Jayawardhanapura in 2014. Also, he is a past finalist of the Chartered Institute of Management Accountants UK. Engineer Jagath Jayasundara, please take the screen to address the audience as our chief guest. Over to you, sir.
Thank you very much, Kulandi, for your detailed description and introduction about me. I am glad to see one of our fellow friends in the audience, Sithila, my batchmate, and yet another industrialist who has done great jobs to the industry. And I read a paper recently. She has they have done certain good work to the industry and awarded for that. And my fellow, the competition like Priyantha, but I may discuss certain in detail insights during this 20-minute presentation, but it is, I don't think it won't be a problem for our inside detail communication to the public. So from the day Dr. Asela spoke to me regarding this requirement, and I was thinking, what should I tell to this bunch of excellent engineers who have excelled their academics and together with their brainy, the excellent academic staff. So if I try to talk about engineering, we all observed. So recently we observed for excellent presentation. So if we talk about engineering, I'll be screwed because we are not in a position to talk about engineering nowadays. Right. So when I tried to find some solutions, so the answer to my own question, I thought in the industry as engineers, there are little or very few C capacity leaders, or the COO, Chief Executives or Chief Operating Officers. So in the hierarchies, there are limited engineers in the country. So I thought of giving my insights to you all as young engineers to inspire your careers based on my understanding. So I have a very okay, right. So is it visible to you all, the screen?
Yes, you are
okay,
clearly
thank you. All right. Right. What I thought to discuss about turning our engineers into corporate leaders. So if we take the global scenario, let's see a 2.5-minute clip, what they are talking about.
Jagath, is there audio in the video?
Yes, Kulani, did you tell something?
Is there some kind of an audio that we have to listen to, because we didn't hear yet?
You didn't hear, fine, okay. So, how?
Origin CEO Jeff Bezos.
No, okay, Kulani?
Yeah.
Okay, fine.
There's one similarity between Amazon and Blue Origin CEO Jeff Bezos, Apple's Tim Cook, Alphabet's Sundar Pichai, AMD's Lisa Su, General Motors' Mary Barra, and NVIDIA's Jensen Huang.
These days, the heads of some of the most successful companies in the world have one thing in common. They're engineers.
For those who aspire to be CEO of a company one day, getting an MBA, a Master of Business Administration degree, used to be the way to go. But that's not so true anymore. Elon Musk went so far as to say, "I think there might be too many MBAs running companies," in an interview with the Wall Street Journal. He thinks those with business degrees spend too much time in board meetings, poring over PowerPoints and finances, when their focus should be on the product. The thinking being that if the product is good, the profits will follow. In the case of Musk, that means building great electric cars at Tesla or great reusable rockets at SpaceX. That's where being an engineer is helpful. Engineers can design, build, create, and improve their product because of their background in math, science, and technology. And they can help solve challenging technical problems that might otherwise scuttle their dreams. Technically, Musk has a degree in physics and economics, not engineering. He's a self-taught engineer who read books to learn about rocket science. When engineering consultant Sandy Munro interviewed him for his YouTube channel, Munro Live, he said it's Musk's knowledge that stands out.
I was blown away. I've seen dozens of CEOs. I've never seen a CEO ever, or a president, that knew more about the product.
That technical know-how that comes with an engineering background goes a long way toward building better products.
Just ask Satya Nadella, the engineer at Microsoft who rose to become CEO. When he took over the top job in 2014, he had to figure out a way to make Microsoft relevant as it faced an onslaught from Apple.
We now need to make Microsoft thrive.
The software company struggled to thrive under the leadership of his predecessor, Steve Ballmer. Its products were far from revolutionary. The Surface was a response to the iPad, the Windows Phone, and answer to the iPhone. Ballmer has a degree in mathematics and economics from Harvard, which helped balance the books, but didn't do much when it comes to innovation. When Nadella took over, he transformed Microsoft, moving its software to non-Windows devices, for example, bringing Microsoft Word to the iPad and the iPhone. He also expanded its cloud business, Azure, which has become the biggest rival to Amazon's AWS. In his first email to employees as CEO, Nadella wrote, "Our industry does not respect tradition. It only respects innovation." That innovative spirit of engineering saved Microsoft.
It's no surprise that engineers make it to the top of the tech industry, which has seen explosive growth over the years. But they're also doing well at non-tech companies.
Like Jeffrey Sprecher, the CEO of the holding company that owns the New York Stock Exchange. He has a degree in chemical engineering.
I've never had a job that had anything to do with chemistry, but the discipline that I went through there taught me about problem solving, and business is really just that.
Right. So let me come into the Sri Lankan context. Actually, from the audience, I may ask small questions. After O-level, what we do, basically, those who have excelled in O-level, either do Meso, Biostream, then finance or the account stream, finally maybe art. So if you take the industry, if you take the corporate leaders, can you count how many in engineering streams? And basically, you might think that those who fail O-level basically control the entire country, right? But it doesn't. This is not a forum to discuss about that. But basically, I believe the brainy IQ people from O-levels and A-levels do not reflect in the industry as industry leaders. That is my personal opinion on that. So if you count industry leaders, engineers versus non-engineers, I think non-engineering corporate leaders are much more. So I was thinking why, what is the reason? So basically, the leadership skills described by Robert Cars. We basically have a lot of technical stuff in the university life. It is witnessed very well. So we basically engage as line managers in the industry. And when we want to climb the corporate ladder, it shows we must have 3 different skills. In addition to the technical skills, the basically human skills, so interpersonal skills, may need constantly throughout the career. But what is the difference? So when you climb the ladder, you need little less technical skills, and you have to enrich and develop your conceptual skills in bigger way. I think that is where most of our engineers are stuck in the industry. So we know what is human skills or the interpersonal skills. We know what is technical skills, but what is called the conceptual skills? I just touch in few minutes. Basically, there is no proper definition what is conceptual skills, but it's basically, it contributes a lot of attributes. Of course, we have to understand about the organizational architecture, which is what the culture, the communication pattern, the objective of this different stakeholders kind of thing. And the strategic thinking. What is called strategic thinking? Always we should look at from the bird's eye view of the bigger picture. What is, why I am doing this? What is the end objective of this? That is basically strategic thinking. And the decision making. Actually, to be a leader, to climb the ladder from the basic engineer to the corporate leaders, actually decision making is the bigger process we must develop ourselves. Other than that, organizing, planning, management process, and ethical judgment, etc. Actually, the empathy or the ethical influence also has to be inculcated to our decision-making process. Then only we can be a successful leaders. So I just touch few tools which may widely used to enhance our decision-making skills. Basically, we know Pareto, risk assessment matrix, Eisenhower matrix. Those are basic tools. Simply we study in different areas in different syllabuses, but we can embed it into our leadership enhancing process. So basically, the Pareto principle we all know, 20-80 rule. Actually this was developed based on the quality management area, but this is a universal tool we can apply everywhere. For an example, in the industries, we have limited resources with unlimited wants. So how you can use your Pareto? So it defines, if you take the turnover or the business segments, you have limited resources to finance to be put into the different sectors, but out of your entire business segments, only 20% represent, or that gives you the 80% of your turnover or either profitability, etc. So you can, in such a way, you can allocate your resources into your prospectful business ventures. Then the other one is when you take decisions, risk assessment matrix, which is developed by SIMA. So basically, you evaluate the risk assessment based on the probability or the likelihood against the impact or the consequence or the harm by occurring that event. So if it is under, actually this has a well-developed area to be taken for the risk management, the personalities, but this is a very simple model I wanted to show you. So if it is ranked under, any event ranked under 1 or 2, you can just ignore, or you just can take small effortless action to reduce or eliminate those. But if some event may rank under 3 or 4, you may have to address it and take actions to eliminate it, because that impacts your business. If it is ranked under high impact and high likelihood, you have to avoid those situations. Those are basic templates where we can use to take our decisions. The Eisenhower matrix, basically, it says how important to you to allocate your time into take decisions. If it is important and urgent, you have to be done at now. Important but less urgent, you can little later do it, or you can schedule it. And urgent but not important, you can delegate it to for different your colleagues or subordinates or etc. And it is not less urgent, it is not urgent as well as not important, you can just omit it, delete it. So likewise, so we have to prioritize what to be attended by our with our limited time as businessmen, so the business managers or the business heads. We have 101 things to do, but we have limited we have to strike the balance between our personal life, corporate lives, some other events, etc. So you have to manage your time very well. And finally, some other useful attributes to be a leader. Actually, those are very important points. You have to have your integrity at all. In the industry, you can find enough technically qualified, very proficient people, but very difficult to find people with integrity. Because when you are climbing the ladder, you are authorized to take decisions, and you are authorized to take decisions, especially the finance, in terms of finance. It may be not in rupees, maybe millions and billions. So the integrity counts a lot. And how you are managing the success and failures. Actually, in our life, everyone we have done mistakes. And we have some success stories as well. How you manage it? Most of the people in the industry we have seen, if there is a success, maybe it may be an outcome of a team effort. But once receive that success, they ran towards boss and say, "Hi boss, I have done this and we have won this. So this is the success story," and try to take the entire credit from the boss or the respective people. If something happens in other way, if fail, what they should do. So I told these people, they didn't do it, they didn't consider my opinion or advice. So that is why this has happened. Oh, telling 1,000 stories, why this was failed, just because of not me, just because of why others. I will share finally small video clip how the leaders manage the success and failures and lead by examples. So basically walk to talk. If I am the head of the department, if I have the team to manage, I'll tell these people, don't rob the company. Hey, but what I do. So especially in the industry, you have to walk to talk. Basically, what you talk should do. And not only that, basically, the accountability, what you all are doing, the accountability is a matter. And another important attribute in the industry, the agility. So actually, the final last presentation was about the lean. So excellent presentation. And they have done their homework very well and understood what is that principle. But if someone asks today, as of now, what is my key attribute in terms of supply chain or the value chain? Whatever the cost, if I have the stuff, I am done. Because, in the industry, you can't open an LC today. You don't have dollars to bring down the stuff. If you talk about the supply chain, the lean, and the ITO, the inventory holding costs, etc., you don't have. If you don't have stuff to sell, what do you do? So recently, actually, I also made this kind of experience from our group perspective. Group CFO sending mails to my finance manager. Hey, look, your inventory has gone up this much. This is this much billions. So this is this much of holding cost for this period. The ITO has increased this much. I said, my finance manager, right to her, everything is right. If you don't have stuff to sell, how do you calculate anything? So agility is most important in the industry. And basically, as engineers, most of the time we take rational decisions. We take the rationals with our mathematical simulations or the rational simulations. And ultimately, one thing we have to be understood, we are dealing with the human beings. We talk about the human relationships. We talk about the conceptual relationships, the conceptual skills, human skills. Actually, we are dealing with human beings. Ultimately, we should show our empathy to our counterparty when we are taking decisions. So that is also the actual, lot more things can be discussed, but with the time actually I have decided to limit for this key attributes which may need to inculcate and develop by ourselves to go to the next level of the next hierarchy. So finally, once again, I thank Dr. Ceylon and the university for giving me this opportunity to address you as the keynote speaker or the chief guest. So thank you, Ceylon. And finally, I just brief you this 2-minute story how the leaders are behaving. And I trust my young friends may absorb certain parameters what we have discussed today to inspire your future.
1979, SLV-3 satellite launch vehicle, I was the project director, mission director. My mission is to put the satellite in the orbit. Thousands of people worked nearly 10 years. I reached the Sriharikota and it's in the launch pad. Countdown was going on. T-minus 4 minutes, T-minus 5 minutes, T-minus 1 minute, T-minus 40 seconds. Computer put a hold, don't launch it. Computer says don't launch it. I am the mission director, I have to take a decision. Everything is on. Behind me there are 6 experts. They saw computer database coming in and screen, and they see the pictures in the screen. They said there's a problem. The problem is there's a leakage in a system, in the control system. But immediately calculation, no problem. We have got sufficient fuel and oxidation for control system. It controls the rocket to the required altitude, and we can go ahead. Now, of course, my expert's view, but I took the decision. Problem is mine. Finally, I took a decision. I bypassed the computer. I launched the system. First stage worked is a 4-stage rocket, and second stage got mad. It went to spin. Instead of putting the satellite in the orbit, it put in the Bay of Bengal. 1979, it was a failure. It was a failure. First time I experienced my failure. How do you manage the failure? Success I can manage. So at that time, a great man, a great leader, Professor Satish Dhawan, he comes to me. I'm very tired working nearly for months. He wakes me up, come, let us go for a press conference. Press is meeting there, like this, number of people, world press, with photos, this and that, all the gadgets, they are there. I was really frightened. I will be the culprit because I'm the project director, mission director. What Satish Dhawan said, chairman, Indian Space Research Organization, said, dear friends, we have failed today. This is the first time I have to give all the success. All the failure is, I want to support my technologists and scientists and staff so that next year they succeed. So he took the whole blame himself. And then media asked, you put Bay of Bengal so many crores, you are putting like that, lot of criticism. He received the criticism. He assured them in a year we will succeed with our team. It's a very good team. Next year, here only interesting happened. Next year, July 18th, 1980, when he succeeded, Professor Dhawan said, you go and conduct the press conference. You follow what it means? It means when the failure occurred, the leader took it up. When the success came, he used his team. That's the first.
Thank you, Kulani. So any questions or any views? So I am prepared to take those. Yes, Sanjeewa, you can
yes,
proceed with your question.
Jayasundara, yeah, we're very impressed by hearing your lecture.
So I just want to ask you now, recent past, there's a lot of import restrictions, and especially the luxury items were banned and all. So your company mainly in the import and retail business here. How did you all manage the situation?
Mainly, as we have done previously, we don't have that luxury to do so. A lot of concerns are there, but as of now, I just forgot your name. Just Sanjeewa, no?
Sanjeewa, yeah.
Yeah, Sanjeewa. As of now, actually, the foreign currency problem has eased up to certain level, but not up to our expectation. But we have to negotiate much on the different suppliers to extend the credit period. Early, actually, once we send the LC or the OA, whatever the documents of the bank, we don't have to think twice. It basically goes. But for the time being, we have to negotiate the extensive credit period with the suppliers. Officially, now the bank is requesting us to give at least 180 days credit period from the suppliers, but it is a risky for the business. That is why, because actually we basically take the credit period of 180 days from the vendor. We get the stuff. We basically sell the product to the customer. We have to do the costing and everything by anticipating what is the expected dollar rate at the maturity, which is after 6 months. But if you overprice, your competition will forgo. If you underprice, your cash will forgo, or you sell at a cost, or sell at a loss. So those are very tricky decisions to be taken these days. But as an engineer, I am encouraged, and I'm very happy. There is a happy movement there, because everyone in the country, maybe the politician, maybe some minister officials, everyone is encouraging us to go for local manufacturing. That is a good trend, and more levies to be imposed for imports in the coming months, probably, and more reliefs will be granted for local manufacturing. So I think as an engineers, we can be happy. So a lot of investments are coming, and a lot of innovations are happening in the country. A lot of value additions are happening in the country. So for engineers and the technical people, a lot of employment will be created in the coming months or coming years. For an example, these days under our company, few billion rupee investment is happening. So that will create a lot of engineering jobs, as well as that will be the unique product to be developed and then manufactured in locally first time. So I don't declare the products for the time being just because of the confidentiality, but that is a very high-tech products to be manufactured in Sri Lanka within basically next couple of years.
Thank you. Thank you.
Thank you.
Thank you very much, Engineer Jagath Jayasundara, for your presence here with us today as our chief guest, even though it's virtual, and our gratitude to you is boundless. We are now moving back to the disseminating of the new knowledge acquired through research by our final year students. So without any further delay, we will move on to the next presentation by Ms. Pechuma Shetunga Manoharan and by Mr. R.A. Ravindu Prabhakar on the design and develop of DOB-based experimental two-wheel Segway setup. Over to you.
Good morning all. Welcome to a final year research presentation of design and development of a disturbance observer based inverted pendulum and extend to a segue prepared for the Industrio 2021 Manufacturing and Industrial Engineering Symposium. The project was carried out by myself, Peshma Manoharan, and my colleague Ravindra Ranasinghe under the supervision of Dr. Achala Pallegadara and Dinesh Kodithuwakku. First of all, to provide you with an abstract of the project, it is mainly based on control systems, and our system of study is an inverted pendulum and a Segway. The Segway is a two-wheeled personal transporter which is an extended version of an inverted pendulum, where both systems are based on the principle of dynamic stability and highly unstable due to the characteristic feature of their inverted position of balance. Or in other words, if we simplify this more, it is all about developing and implementing a controller to automatically control a broomstick in an inverted position on our palm. So this project is a full system design, including mechanical hardware design, electronic assembly, and the feedback controller implementation. The stabilization at an inverted position of the Segway is accomplished through PID controller implementation, and the study of PID-based DOB controller on inverted pendulum is extended to the Segway system. Moving to the problem statement, the problem of these types of highly unstable system is how to maintain in an upright position their base is moving forward and backward, as well as when disturbances are subjected to the system. Also, is there any way other than traditional PID controllers to enhance the stability and robustness of the Segway system? Hence, we propose the implementation of the control technique PID-based disturbance observer controller to our system, which we believed that the technique would allow the controller to estimate and compensate for the disturbance and smoothen out the system outputs. We set a scope of designing and developing a Segway setup and attain the equilibrium using PID-based control techniques. As objectives, to build an experimental Segway setup, attain self-balancing equilibrium, and extend the controller of PID-based DOB of inverted pendulum to Segway system for further study. Moving on to methodology. We divided our approach into two pillars of study, the inverted pendulum system and the Segway system, and then extend the study of inverted pendulum to the Segway setup. This systematic approach led us to many findings, and let me take you through the results and discussion section of the presentation. Our primary objective was to build an experimental setup for the Segway, and as shown in Table 1, mechanical assembly consists of the chassis, axle and wheels, power transmission, and the handle. Feedback and actuator network falls under the electronic assembly of the system. And in order to elaborate the secondary objective, we have prepared a short video clip for your convenience. Let me play it for you. Alright, moving on with the presentation, let's look at the analytical representation of the data collected from the system. Figure 1 and Figure 2 show the plots obtained after implementing PID controller for the Segway system. Also, the comparison shows the tuned and an untuned state of the system. Tuned state shows less fluctuations around the set point value. Moving on towards the disturbance observer control application, first we implemented the disturbance observer control block to the inverted pendulum setup for simplicity and to observe how it impacts the stability. Figure 3 and Figure 4 is the comparison between the pendulum angle error variation with time without DOB implementation and after DOB implementation respectively. As you can see, after the DOB implementation, system shows better stability. Similarly, for chord position error variation with DOB and without DOB shows how DOB controller supports the system to reach a steady state, whereas without DOB, the system keeps fluctuating randomly. Moving on to the most important representation, the Figure 7 plot is derived while the pendulum was subjected to an external disturbance. This represents the external torque disturbance, or in other terms, we can call this as disturbance current since torque can be directly connected with current. Also, this current value would be the current required by the system to overcome the disturbance. To explain further, the blue color line is the pendulum angle variation and the boxed areas are the instances where the system was subjected to disturbance. The purple color line shows the disturbance torque represented in current values, and it is the current requirement by the system to address the disturbance. Moving on to conclusion. So considering all the analysis, we were able to come to a conclusion that the controller is capable of enhancing robustness and responsiveness to disturbances and interrelate the similar behaviors between inverted pendulum and the Segway system. Also to highlight, disturbance appear in many forms, can be categorized into three main segments as disturbance on motor, pendulum, as well as disturbance caused by the terrain. Before wrapping up the presentation, you may have a doubt that where to apply all these systems and theories. Well, it is very popular in European countries where you can gear up Segway to logistic activities, security, and rescue, also as an eye-catching advertising strategy. Further, Segways can be used for tourism, sports, as well as for adventurous activities. To clear out where to apply this particular control theory in the manufacturing industry, well, let me give you two examples where most of the manufacturing and industrial engineers are familiar with. One would be in motor controlling application of computer numerical control machinery, and other would be the conveyor belt control applications. Likewise, it is applicable for many more applications where motor controlling is involved. This controller implementation can finally result in precise and quality control, smooth flow of material, even against changing load disturbances, etc. Finally, these are the challenges and key learnings from the project. Challenges would be mainly the mechanical fabrication and motor modification due to pandemic situation in the country, as well as the PID tuning of parameters since we use trial and error method. Key learnings would be understanding the theory related to control systems and PIDs, as well as the software handling area related to coding and programming. Here are the references which we referred to proceed with our research. Thank you.
Ladies and gentlemen, that was Ms. Pechuma Manoharan and Mr. Ravindra Ranasinghe on their project. So just like before, if you have any questions coming their way, please feel free to raise hand and speak up or type your questions in the Q&A session. We have a question from Professor Gamini Dissanayake. Go on, sir.
That's a very interesting presentation. It's all the way from design theory and then manufacturing, programming to experimentation. So it's very impressive. Thank you. Well done. The question I have is more comment rather than, yeah. So early segways had a problem. When you lift one of the wheels, it goes unstable. So that was a problem in their control system. So I'm just wondering whether you actually pushed your control system to a limit where it actually fails. So in other words, what are the failure modes you observed during your experiments?
Yeah, so talking about the traditional segways, now in our system, we only, our scope was only to balance it in a linear position, in a planar orientation. So the differential drive is not, we didn't consider that in our study, in our scope. So talking about the failure modes, there was we were able to find the range of the workable range of the segway. Say roughly it was like 15 degrees. I mean, if you take 0 as the upright position, it's like for this particular application, it was like roughly minus 15 to plus 15 degrees working range. So and talking about collapsing situations, like I said, we were able to find 3 types of disturbances, especially now say the system, the 3 types are the motor disturbance on motor. That means the disturbances experienced by the motor shaft. So say there is a bumper on the terrain, or say some kind of a pit, or any sort of a buffer, any sort of disturbance, it can translate to the motor shaft, and the system will experience a disturbance in that sense. And then talking about the pendulum, the disturbances on pendulum, the rider acts as the pendulum in the segway. So if you compare the inverted pendulum and the segway, the pendulum in the segway pendulum is the human rider and the handle. So his movements, or his or her movements and posture can cause disturbances. And also one more thing, unmodeled parameters. Say now in motors, there are a lot of friction inside, inertia, disturbances, etc. So these are not visible from the outside. So to address that also, we can implement this controller. So those are the
yeah, thank you. That's a very good answer. So I'm really pleased that you actually pushed it to the limit and see when it fails, which is very important in this kind of situation. You know that it will work in some scenarios, but you also know that when it doesn't work, which is great. Good, thank you.
Yeah, thanks.
Thank you for that question, and we'll wait a few more. Yeah, we have another question. Please go on.
Yes. I just want to ask 2 questions. One thing, ladies and gentlemen, do you check this with the loading condition? Now you have made the model with unloading condition. Did you check with the some loading? And my second question, is there any possibility of developing this kind of unit for material handling inside the industry? That is my question.
To answer to your question, we haven't done any procedures to load. So simply our main target was to balance it like without any external loading. But for inverted pendulum, we were able to add another mass, which is with the wine glass with water. But for the segway, we are still progressing, and we are still on the project. We hope that we can do something related to loading some weights and see whether we can balance it with the PID with DOB based control technique. And as for your other question for material handling, if we can stabilize the Segway setup with a PID with DOB system, we might be able to use it for material handling, which we hope. And Ravindu, do you want to add something?
Yeah, I mean, in the presentation, like Pechma mentioned in the presentation, there are many countries using these segways for logistic purposes, say for warehouse handling and for security stuff as well. So, but the thing is, this DOB application, the disturbance observer controller is still in a research level, as we found out. I mean, it was developed by the Japanese, so it's still trying to come into the industry. So, like I said, if we can implement this, material handling will be, we can rely on that, because sometimes payloads can change. You can have a high working range, and the disturbances on the track can be addressed. So many more advantages can be obtained from this. Yeah.
Right. Thank you very much. It's a good project. I think you can continue to the developed level for material handling where the Japanese stop. You can do the further research on this. Thank you very much.
Yeah. Thank you.
Let's see if there are any more questions coming up, and wait a few seconds. It looks like that was the last question for this project. So thank you, Mr. Ravindu and Ms. Pechuma. And moving on to our next presentation. This will be on developing and testing a lean Kaizen conceptual model, a case study at a foundry industry by Ms. Senuri Gurusingha and Mr. W.A. Ayubi. Over to you.
Hello, everyone. I am Senuri Gurusingha, along with my project partner Ishar Udit. Today, we are here to present our final year project presentation at Industrio. Our project title was The Lean Kaizen Performance Relationship in Manufacturing Sector, Developing and Testing a Lean Kaizen Conceptual Model, which was done under the guidance of Dr. Pramila Gamage, Senior Lecturer in our own department. During this presentation, we will take you through the items shown in the slides, mainly the problem statement, scope and objectives, methodology, results and conclusion, further improvements. Companies tend to use different manufacturing strategies like Lean, Kaizen, Six Sigma in order to improve the processes and hence increase their financial profits. When referring to the literature, what we found out was that there are many publications which explains the importance of integrating a mix of but overlapping manufacturing strategies to achieve desired manufacturing performances. However, although many organizations try to implement such strategies, sustaining them in the manufacturing environment has become extremely challenging due to various factors. One of the reasons is that the implementation is done without a proper awareness. And the second one is the change in operational culture. Scope of our project was to develop a conceptual model for implementing Lean in Sri Lankan manufacturing sector and to develop a conceptual model through literature review and thereafter carry out a testing using online data collection platform. The aim was to study the applicability of Lean Kaizen conceptual model for organizations. When it comes to objectives, there were three, which was to develop a theoretical model, to develop a questionnaire by operationalizing the constructs, finally, the model testing and validation. Taking you through the literature review, we divided the literature review into two parts. First one is Lean Manufacturing and Kaizen. As I mentioned, many organizations struggle to sustain in this new customer-driven and global competitive market. Therefore, they look up for different strategies to overcome those issues. When defining lean, it can be defined as a systematic approach to identifying and eliminating waste through continuous improvement, flowing the product at a pull of customer in pursuit of perfection. The word Kaizen indicates a process of continuous improvement. According to many research articles, there were many barriers to successful lean and Kaizen implementation. As you can see in this slide, we have shown the drivers and the barriers for successful lean manufacturing and Kaizen implementation. For drivers, either it can be financial benefits, customer focus, and changing culture. When in terms of barriers, it can be financial barriers, management, and the workforce. Second part of our literature review is structural equation modeling. Structural equation modeling, or simply SEM, is used to model and test relationships with directly unobservable parameters using a measurement system directly involved with measurable variables. There are two types of SEMs, which is covariance-based SEM as well as partial least square SEM. During our project, what we used was covariance-based SEM. Moving on to the methodology, the first step we took was to develop a theoretical model. This was done purely based upon the past literature, and we came across a model between three variables: lean manufacturing, Kaizen, and manufacturing performance outcomes, which you will be able to see in the coming up minutes. The second stage was the questionnaire development. This was indeed a very challenging task for us. However, we operationalized the three variables into 38 statements in total, and the questionnaire consists of demographic data analysis section as well, so that we can get a clear idea about our respondents. Third stage was peer review and pilot testing. After peer review done by one of our academics, we conducted a pilot testing using a few people from the industry and did some minor changes to our survey based on the feedback received. The next one was data collection. Initially, the project was planned to conduct in an organization, collecting data physically. However, due to the pandemic, we were unable to do so. Adapting to the new normal, we took a new challenge to collect data virtually through online form, sharing it among the selected sample population. During this, we mainly considered the industries like Apple, FMCG, dairy, PPN, etc. Remaining steps and their results will be explained in the coming up slides. This is the model which we developed using the literature at the initial stage, which consists of three hypotheses. H1, lean manufacturing system and Kaizen are positively correlated. H2, Kaizen has a direct positive effect on manufacturing process outcomes. H3, lean manufacturing system has a positive indirect effect on manufacturing process outcomes through Kaizen. Taking you through the demographic data analysis, when we consider our respondent pool, mainly from males, and they represented the following industries: Apparel, FMCG, PP, and dairy. And most of the people who have responded to our survey are our managers. In order to continue our presentation, I will invite my project partner, Jagath. Over to you.
Thank you, Sandri. As for our first step to calculation process, we were done the absence of common method bias. So for that, Harman single factor test can be used to verify the absence of common method bias in the survey responses. Harman single factor test seek whether or not a single factor extracts the variability of all questionnaire items in a measurement instrument. If a single factor extracts the variability of the questionnaire items, according to the Harman single factor test, the responses are treated as suspects or biased. The principal component analysis, or as known as PCA, method can be determine how many factors or components are required to extract the variability of the 38 questionnaire items in the questionnaire. The script plot of PCA can show that the result do not suffer from substantial common method bias. As the next stage, we conduct a dimension reduction as shown to extract the best explaining measurements. So move on to the next slide. In order to obtain a better fit, we parcel the item as shown. Through that, we have reduced the total indicators to 8 number of construct. Both Kaizen and manufacturing performance was parceled using the factor loadings and lean using Likers 4Ps. As per the table, there is a significant improvement in the parameters we considered. So moving on. Then the value of global goodness of fit indicators for the CFA model and the theoretical model are at a good fit to the data when the questionnaire items are parceled. In the case of not parcel, results do not meet the criteria of CFI and P clause. Therefore, this shows that the items parceling is a requirement. So then, convergent validity and discriminant validity of the construct is another important aspect after establishing the factorial validity through CFA. Table shows the loadings and cross loadings values, which clearly shows that the construct shows convergent and discriminant validity. By having scale reliability, construct validity, and discriminant validity, it was concluded that parcel measures are valid to operationalize the constructs. Therefore, the constructs are good to identify the structural relationships among the construct with the test result of 3 hypotheses, H1, H2, and H3. So as for our conclusion, the figure indicates the parameter estimates of the relationship among the constructs which were developed initially. Hypothesis H3, or known as lean manufacturing has a direct positive effect on manufacturing process outcomes, is not supported by the data. So there is p-value is less than 0.05 and it's not significant. But lean manufacturing system shows a strong and significant effect on manufacturing process outcomes through Kaizen, which plays a mediating role. The R-square value is equal to 0.65, meaning that the fitted regression model explains 65% of variation of the manufacturing performance outcomes. The empirical result shows that manufacturing performance have no or very less effect from lean, but indirectly related to the mediating effect of Kaizen. By logical extension, the finding of this study provides support for the adaptation of lean to enhance the manufacturing process outcome is more realistic and sustained with Kaizen culture compared to implementing lean philosophy itself. So moving on, and as for the further improvement, this study can be extended to see the validity of proposed theoretical model for SMEs in Sri Lankan context. So as for our challenges and key learnings, listed down are the challenges that we had to face, mainly with current situation of the country. However, we were able to successfully adapt and overcome the challenges with support of our stakeholders. So finally, at last but not least, we would like to take this opportunity to thank our project supervisor, Dr. Pamela Gamage, for her continuous guidance and support throughout the project, and to all our academic staff, friends, and our beloved parents for supporting us. Further, to all the people who have joined hands with this event and the organization committee for organizing and such a great platform to showcase our learning. Wishing everyone a nice day. Thank you.
Dear attendees, that was the result of hard work of Ms. Senuri Gurusinghe and Mr. W.A.I.Izzi. As usual, if you have any questions, please raise your hand or type the question in the Q&A section. Yes, Mr. Ashok Bandara, you can go on.
Yes, thank you very much, Chenori and Udit, for your good presentation, very good study. And I would like to know, since you said you had no chance to go to physically to collect data, what are the techniques you use to prepare a good questionnaire? How do you capture correct data for this project?
So thank you for your question. So before answering the question, I would like to apologize on behalf of my project partner for not be presenting today due to urgent situation at his workplace. So answering to your question, Mr. Asoka, so initially after we developed this theoretical model, which we had three components, which is lean manufacturing, Kaizen, and manufacturing process outcomes. The next biggest task was for us to operationalize it. So initially, for lean manufacturing specifically, we consider the Likers 4 Ps. And for Kaizen and manufacturing process outcomes, also based on the literature review, based on the case studies, we developed these 38 statements, which represents those three variables that we were considering. And after that only we came across with a questionnaire, and which includes a demographic and data collection as well, which we spread among the selected sample through virtual platform. So thereafter we carried out this data analytics and came across these conclusions.
Okay, thank you.
Let's wait a few more seconds to check if there are any other questions. It seems like that there are no other questions coming for this project. So thank you very much, Ms. Sanjeewa. So we will move on to our next project now. This will be the last project that will be presented in the Industrio 2021. It is about real-time process monitoring and visualization of an apparel solving module by Mr. I.U. Munasinghe. Over to you.
A good day to everyone. I'm Mr. Munasinghe, and this is my presentation for the project number 26, real-time process monitoring and visualization of an apparel sewing module. This is an individual project, and I will be narrating the whole presentation. Apparel industry is one of the leading industries in Sri Lanka, and Sri Lanka is one of the top apparel producing countries in the world. Apparel industry of the country employs about 15% of the country's workforce, accounting for about half of the country's total exports. Performance evaluation data is a major source of information in improving manufacturing systems. Usually, performance measures are taken manually in the apparel industry, but due to the fast-moving nature, it is difficult to take performance measures manually. So, there is a need for performance evaluation process to be automated, so the Sri Lankan apparel industry can be competed at global level. This is an ongoing project, and in this phase, our objectives are to upgrade the visualization system and to design a customized data acquisition method to address different types of machines and operations. As for the visualization system, we are mainly focused on a real-time update in Yamasumi chart, and we designed the data acquisition system mainly focused on that as well. So that's our scope in this phase. This is the project overview. So I'll explain briefly. So we are acquiring data from workstations using sensors which are connected to a microcontroller. Each workstation is equipped with a microcontroller, and all the microcontrollers in the sewing line are connected to a Raspberry Pi module. Each Raspberry Pi will have a touchscreen with a graphical user interface to enter details like breakdown data, standard make values, and employee data. All the data collected by Raspberry Pi module will be directed to a cloud database. Then we use Microsoft Power BI to visualize these data. so that the performance can be observed real time and take necessary actions to improve productivity. Also, this data can be analyzed further to give predictions and find anomalies in the system. So this is the methodology. Initially, I did a background study and a literature review, but literature related to apparel industry with IoT was low. So in order to get more insights, I connected people from the industry who has more knowledge in this area, and I got a lot of valuable inputs from them. Then I worked on the two main objectives separately. So I'll start with the modification of data visualization system. Initially, I assessed the current visualization system, which is the web application I designed in PR410. Then I compared it with the alternative data visualization methods suggested from the industry. The main problem with the current visualization system was I couldn't generate the takt timeline in the Yamasumi chart. So I had to find a method to generate a clustered column chart with a horizontal line. Also, I considered about the data connections, accessibility, and the user friendliness as well. After considering all these factors, I ended up using Microsoft Power BI for data visualization. Going into the second objective, there are different types of operations and workstations in a sewing line. So initially, I studied about the types of machines and operations. Then I designed several data acquisition methods, and I discussed with them with the industry personnel and got feedback. After that, I did several improvements to the selected design and tested it using with an old sewing machine at our home. Then I finalized a design and validated those data. Then I integrated both these systems to the main project, and I did required alterations to the system as well. After that, I did a pilot run at domestic conditions, and it was successful. It was unfortunate that we couldn't do a pilot run at the industry. This is a summary of the literature review I did. I'm not going to explain it because the time is limited. So let's go into the results and discussion part. So our first objective, modification of data visualization system. A Yamasumi chart is a stacked column chart that shows cycle time in a given operation, and these cycle times can be divided into two parts, value added and non-value added. On the left side, you can see the Yamasumi chart I generated for PR410. There were several drawbacks in this Yamasumi chart. I was unable to generate the takt timeline and it was less user-friendly. So we needed a more dynamic and user-friendly way of visualizing performance data. Then an industrial personnel suggested me this software called Microsoft Power BI. It's a business analytics service provided by Microsoft to provide interactive visualizations, reports, and dashboards. So using Microsoft Power BI, I managed to generate the required Yamasumi chart with the takt timeline as shown in figure 4. Takt time is basically the rate which you need to complete a product to meet customer demand. So if the cycle time goes beyond the takt timeline, it is a clear indication that the order is going to be late. And I didn't stop there. It was suggested from the industry that the minimum and maximum cycle time of an operator are also important performance measures. So I developed a system to visualize the maximum and minimum cycle time of each workstation along with their average cycle time. Addition to that, Power BI has a mobile application as well, so the authorized parties can view the performance data with their mobile. Our second objective was to design a customized data acquisition method from workstations. Figure 9 shows the initial method we had. It was a method to push a button after each workpiece is finished, and this was a major concern, and everyone suggested to go for an alternative method. I think I don't even have to highlight the drawbacks of it. So As I said in the methodology, I studied the sieving operations first, and then I tested several designs using an old sieving machine at our home. So finally, I came up with a method of using a single IR sensor to track cycle time by placing the IR sensor right next to the needle and keeping a sticker underneath that, as shown in figure 9. It was also suggested to use the current variation of the sieving machine to track the cycle times. I did research on that as well, but I couldn't do much testing on that because sieving machine at our home was a manually operated one. So I moved forward with the IR sensor method and I validated those data. Figure 10 shows the extracted data after doing a trial run at domestic conditions. And I wanted to learn IoT at the first place. That's why I took this project. So this has been an overall learning process, and I can say that I'm capable of carrying out an entire IoT project from data acquisition to data visualization. While doing so, I managed to learn several programming languages, web application development, database management, cloud platforms, PCB designing, and the list goes on. So the project does not end here. There are a lot of things can be done in the coming phases of the project. Currently, we are visualizing Yamasumi chart, but we can extend the project to visualize more details like the learning curve of an operator, overall department efficiency, and I did research on tracking cycle times using variation of current following the suggestions that I got. And I ended up with this sensor called ACS712. It's a Hall effect sensor. It's a stable and generate low noise. I think this has to be tested under industrial conditions and compare with the current method to see which one is more viable. And if we could make this system to use minimum amount of energy, this would be a significant improvement as well. So this was the timeline for the project, and these are my references. So that ends my presentation, and I would like to thank the Department of Manufacturing and Industrial Engineering for giving me this opportunity, and thank you very much for your time. Thank you.
Ladies and gentlemen, that was our last student present of the day, Mr. Isuru Munasinghe. So please bring out your curiosity and ask any questions that you have. Just to remind you that you can raise your hand and ask questions, or either type your questions in the Q&A part. It seems like that Mr. Isuru Munasinghe has explained everything really well, that there are no questions coming for him. So that ends the presentation sessions. We hope that this chance gave all our researchers a sense of achievement and responsibility towards fulfilling your further commitment in your journey of research. Despite the distance and challenges we have to face due to the pandemic, us at MEA tried to bring together field experts to conduct a panel discussion. So last but not least, to steer with an interesting topic for today, manufacturing and industrial engineers' contribution to the sustainable transformation of the industry, let me hand over the session to our panel discussion moderator. He is Mr. Rajiv Karunanayake, an immediate passed out from the Department of Manufacturing and Industrial Engineering, Industrio of Peradeniya, and who is currently working as a management trainee for supply chain at Unilever Sri Lanka. Over to you, Mr. Rajiv.
Thanks a lot, Kulani. So as Kulani just mentioned, I hope everyone can hear me right. Please, if someone can confirm.
Clearly.
Great, thank you. So as Kulani just mentioned, we had a great day full of very interesting projects and researchers. And also we listened to two very insightful keynote speeches and of course other speeches as well. So yeah, we are now about to start the panel discussion. And so for this panel discussion, we have invited 5 very important guests. Why do I consider them very important? I would say they're very close to our hearts because all these guests are from the University of Peradeniya, and they have achieved great heights in various different fields. So let me first introduce the 5 guests, the 5 panelists that will take part, who will take part in this panel discussion. So firstly, we have Mr. Sanjeewa Jayasundara. He's the head of supply chain management at Ceylon Cold Stores, managed by Keells Holdings. And he is a personality with over 25 years of experience in the field of manufacturing and supply chain. So really excited to hear and get a glimpse of your experience and insight. And then we have Mr. Thilan Samarawickrama, the director CEO of Eco Films Private Limited, and also he's a founder of Eco Sustainables, a recent startup. And then we have and just to give a glimpse of what his startups are about, it focuses on sustainable packaging and relates to circular plastic economy. So very very applicable to today's theme of the panel discussion. And then we have Ms. Sithila Dassanayake, the director of technology innovation at Twinery by MS. And she's also a person very passionate for innovation and business transformation. Of course, she has a lot more under her belt, but due to the restriction of time, I will keep all these introductions very short. And then we have Mr. Maleen Jayasuriya, he's a research engineer focusing on robot perception, localization, and artificial intelligence. And he's currently a temporary lecturer at the University of Peradeniya. And finally, we have Mr. Priyantha Wettewa. He's the factory manager of Regnis Appliances of Singer, Sri Lanka. So we have a very diverse set of panelists from various fields. So I'm very sure that this panel discussion will be very interesting, and I'm very sure that the audience would learn a lot and gain a lot of valuable insight from this panel discussion. All right. So to start off, so as I mentioned, this panel discussion is about the main theme of the panel discussion is about the sustainable transformation of the manufacturing industry. But as I rightly mentioned, with such a diverse panel, adding up to decades of experience and tons of knowledge, I believe the audience will greatly benefit if we initiate the conversation by getting an understanding on the world out there for manufacturing engineers, because many of us are either recent graduates or undergraduates. So we'll very soon enter the world out there full of opportunities. Whether you want to continue your education, or whether you want to start your business, or whether you want to start a job in a corporate, wherever, let's try to get an understanding on how it is out there. So my first question is directed to Mr. Sanjeewa. Yes, so my first question is to Mr. Sanjeewa, who has over 25 years experience, more than my whole lifetime. So therefore, I believe you would have witnessed in firsthand the many changes that occurred in the industry during the past years, right? So during the recent past, or during your whole career of 25 years, what do you think the major changes are? But what major changes have you witnessed in the manufacturing industry, and how did you really adjust to these changes? I think that will be very insightful. The second part of the question: how did you change, and what were the changes that you have witnessed, and how did you adjust yourself to combat and face these challenges and changes? Mrs. Sanjeewa?
Yeah. Yes. Thank you, Rajiv.
And first of all, I'm also very happy about the standard you all maintain in your projects. All the presentations are very high standard and very well in detail. They have gone into their studies. But unfortunately, I had to do some traveling today, so I could ask questions and actively involved in presentations. So sorry for that. So back into your question. Yes, Rajiv. Actually, I have over these years, I have the leading multinational experience as well as the current my local company experience. So there were a lot of changes. Actually, we also like moved from normal even the labor force from unskilled to multi-skilled, and change the whole operation, like who run the machines as well as they do the maintenance. So that change we have done. So that's the knowledge and the skill set we have improved, and that given a lot of impacts to the business. The efficiencies have gone up because everybody operates the line, knows the technicalities, they have the engineering background, so they know what is happening. So they are fully conversant with the operation. So that gave a lot of benefits. So almost all the plants now we have shifted to multi-skill concept. That is one thing from the human capital, the major change we have gone into. And the other aspect, some presentations also we heard about the industry 4.0 and lean and all. So we also gradually moving into those new concepts. So I think in Sri Lanka, most of the industries are going with the trend and moving into those newer tools and getting the results out of that. So we as engineers, like if we push for the new technology and the need of the industry, so we can do that. So that I'm fully confident that if we drive those tools in our organizations, we can go for it and get better results. So from that front, the modern tools, most of the leading organizations these days are like adopting. So that's another major change. On the other hand, the technology actually, because we are now it's a one world, and so what we produce should compete with all the international brands, or even in Sri Lanka we get all the international products. So we have to produce up to the maximum quality. So to maintain the maximum quality, we have to go for the best technology. So that also understood by the industry, and everybody who is doing a good product, who is competing with the international brands, they go for the highest technology. So that those changes, I can say about 15, 20 years ago, that was not the trend. We do with the low cost machinery and we do with low quality material and all, but now it's not the case. We have the leading edge technology as well as best material, and we are competing with the international brands. You can say in my present company, we are competing with the leading multinationals, Pepsi, Coke. So we can't compete with them without having the leading edge technology and all the know-how. So that's happening, and those are the major changes I can see over my career. But those most of them are very positive, and we are heading to the right direction. And our engineers and the managers are like their knowledge base there's no any gap versus the international graduates. So we are going in the right direction. See, would say we have very good opportunity to develop our manufacturing. That's mainly our production department is onto it. So the manufacturing sector can be like compete with the world, and we can win the world. We are in the right direction, I would say, with our changes we are happening. Thank you.
Yeah, thank you. Very insightful I think there's a lot to learn from what you said. Number one, it's very important to be multi-skilled and multi-talented, not just stick to one area and just learn, just be good at that area only. It's very important to know a bit of everything. And of course, being a lifelong learner is very important because it's very volatile. Everything is very volatile. It changes by the day. And you spoke about positive changes, right? You used the word positive changes, that most of these changes are very positive. And that brings me to the theme of this panel discussion, which is the change or the transition of the current manufacturing industry into being more sustainable, to being more environmental friendly, to being more socially sustainable. And together with that, we talk about the triple bottom line to be, being economically sustainable. So coming into that topic, as manufacturing engineers, I think it is a huge responsibility for us, because I believe everyone would agree on the fact that we are on a climate crisis. There's a huge scarcity of resources, and it is very important that we as manufacturing engineers step up and change how production and manufacturing happens in such a way that it does not burden the world. So that brings me so since this is this is not a new concept, but it might be new to some people, right? But it's definitely not new to Mr. Thilan, who has a lot of experience in terms of sustainability. He has founded 2 organizations and much more experience under his belt. So my question to you, Mr. Thilan, is how practical is this reality? Switching into sustainable packaging, or trying to understand your carbon footprint, reducing it, creating a circular economy. How practical is this? That is my question in reality.
Yeah. Thank you, Rajiv. Now, first of all, let me little bit of coming to the area of sustainability. So what is meant by sustainability? The sustainability in simple terms, it's meeting the today generation's need without compromising the ability of the future generations to meet their needs. So in simple terms, what we say, we use certain resources to meet our needs, but it should not compromise the needs of the future generation. Now, that is the whole concept of sustainability. Now, this is a very interesting and the ongoing topic in manufacturing, not in the manufacturing, the business world. Now, the concepts of manufacturing, it's now if it comes to the mainly in the manufacturing, or we call the supply of goods. Now, if you look at historically the economic model that operates is which we call a linear economical model. What happens is you make, you use, and you dispose, which you basically deplete quite a lot of resources. Now, what happens is now with the increase of resource depletion, now the world is looking at moving into a thing called circular economy, which you basically what you do, you make, use, then dispose, and then you reuse. So it's basically, if you look at in that concept, there will be a substantial amount of resources that's been used at the initial life cycle, being reused at the second life cycle. So we call it's the life cycle expansion of products in different formats. So that is one of the key things that is in the business world today. And if you look at this is mainly this concept is generally today is governed by a foundation called Ellen MacArthur Foundation of UK, which is basically almost we call the circularity models, sustainability models, and kind of calculations is the main resource base which is available in today. Because if you look at under this area, there's no much of a higher study opportunities still has come through. Only I think one master's degree in US is there. Apart from that, in this particular area, there's no we call a specific guidelines being developed, and there's no, even the standards are not being developed for an example, if you look at ISO is there for quality, and then the ISO 14000 is there for environment, but there is no such a thing called a governed standard for this sustainability. Now the sustainability, there's a one standard called British standards there, BS 8001, which is it's not a mandatory standard, but it's kind of a guideline which gives organizations to check whether they are in line with the, which we call the sustainable practices. Now, apart from the sustainability, I told about the coming from linear economy to circular economy. That's one concept. And how the next one is, now if when it comes to the Sri Lankan context, what we can do is we move from fossil fuel to renewable fuel or renewable resources. So that is one of the key areas that quite a lot of industries in Sri Lanka at the moment moving. So it's either it could be the power generation or the consumption of the power moving from the we call the main grid electricity to go into the solar power. So that is one of the simple examples of moving into the sustainability. The key thing is, now if you look at it in a very broad way, now to analyze whether your product is a sustainable product, what we should do is we should do a life cycle analysis of your product, which basically counts the environmental effect of from the raw material extraction to the disposal of your product. So where it shows where the exactly how much of energy being or how much of environmental impacts being happened. So that basically shows you whether your product is sustainable or not. So these are some of the key things that is today's manufacturing and the industries are using in order to measure the sustainability. Now, and if you come into the Sri Lankan context, because these are broader things, and what we can do is if you come into my industry, which I am into the flexible packaging. Now, one of the key things that what we do is phasing out a little bit of fossil-based raw material, which we call the normal polyethylene, polypropylene, or kind of material, towards the bio-based products. Now, the fossil fuel are basically we call non-renewable resource, right? And moving out of the bio-based, which is a renewable resource because it extracts from the plant-based materials. So that is a clear example of how industry could move their packaging from non-sustainable towards sustainable. But when it comes to that, all industries face a trade-off between your sustainability plus the cost. So it's always there's a trade-off. So as an industry, when you're trying to move into the sustainability, always you have to balance between the cost and as well as the environmental impact. So that is one of the key things as an industry that I'm representing happens. And apart from that, I do quite a lot of work on different industries. But every time when it goes to the industry, what we find is the trade-off between the cost and the environmental benefit. But what happens is now the cost is directly, it's very short term, right? The companies, when you go to sustainability or sustainable practices, will have a negative, I would say, impact on the bottom line, which is very visible within 1 or 2 months or yearly financial statements. But the contribution what they are making to the environment and to the society doesn't reflect immediately. So it's a long term. So the companies has to have a clear balance of what is their short term objectives and as well as the long term objective. But with the way the world is progressing, yes, obviously this is an area which quite a lot of industries, not even the developed world and developing world, has to adapt.
Thank you, Thilan, Mr. Thilan. I think you rightly answered the question, which was, so I think to understand how realistic it is, we need to, we have to do a life cycle analysis and then try to understand the cost, also do a cost benefit analysis. And also just, I think we need to be patient and looking to the long-term benefits without completely relying on the short-term benefits. So thanks for that really great insight. which really brings me, I think you paved the way for the next question, which is to Miss Sithila. So in terms of in terms of measuring the cost, right? So I think we spoke about, we've learned, I mean, actually under Mr. Dr. Aseda, we've learned about the triple bottom line when it comes to sustainability, and the economic viability is one part of it. And given that MAs, the apparel industry in whole, not just MAs, the apparel industry in a whole plays a big part in the Sri Lankan economy, it contributes a lot. And so how, like, what business value does sustainability have in terms of the apparel industry? I'm directing this question to you because you are directly a part of the many innovation projects that are underway. So is sustainability taken into account? And if it is taken into account, I'm assuming that it comes to cost. So how do you really factor this in cost? Factor this cost in? Does it really have a business value, or is it just for the sake of the environment? If you can elaborate on this, Ms. Sithila.
So thank you very much for that question, Rajiv. There's no 2-minute answer for this, but I'll try to be brief as possible. If you look at, to answer your question, how important it is to our company, I can tell you 2 things. One thing, we have a different team or a pillar looking at sustainability, as you rightly said, not only on environmental sustainability, but as a whole. Economic sustainability is not a big part of that team because there are the boards and such looking at that side. However, on social sustainability side, HR, there's a different, again, a pillar under corporate HR looking at it. However, the environmental sustainability for processes and products that we do, that team is led by the chairman's son. So that is the importance that you can, we can infer what the importance that company gives to that. And in apparel industry, not only us, I think a lot of companies in Sri Lanka is practicing sustainable practices because it's the right thing to do, not to create monetary value. That is what I have seen a lot. However, it is good if we can monetize it, for sure. So for example, the projects like creating polyester garments through thrown away PET bottles. If you look at it, this is a nice project. It's a nice project to do. But as a world, what we should be doing first is to stop using PET bottles, right? So when you look at this, it's a very complex problem. For example, just the panelist before me talked about using bio-based materials. However, if you look at apparel industry, there are some indices to look at a product sustainability. So it is not only based on the raw material you use, it is not only based on the energy that you use and what energy you use, it is a life cycle assessment. So if you look at, is cotton better than nylon or polyester? There are some indices showing it's not. Why? For example, cotton uses a lot of water, and cotton is using the areas that you can use to cultivate food. So actually to process cotton, the energy you use, the water you use to grow it is much more. So there's this Higgs index, the index that's being used in some of the biggest apparel companies in the world. According to his Higgs index, polyester is much more sustainable than cotton. So you look at it in different ways. However, you ask the question how important it is to us and into the industry. So it's the industries are not existing, or we are not existing for the sake of technology, right? We have to understand what the needs are in the bigger market, where the world is going. And we have to cater to these needs through technology, but sustainably. As you rightly said, it should be environmental, social, as well as economic. So in this space, what we see is more and more the younger generation is looking at, even whether it's a garment, whether it's whatever the product, more than our generation, the coming generations are looking at the experience rather than experience and expression of themselves through what they use. So in that case, we have seen that more and more they look at what do they look at what companies do, what these big giant companies do, what they stand for when they purchase a product. So in that case, for if you are a company that is not honoring this environment, I don't think you have a long life here as a company. So that is understood, and that's why there are so many projects. So we have not only the sustainability pillar is doing these projects, there are innovative projects. So for example, Rajiv, it is good to understand as any company, right? Any company, the technology arm or the innovation arm has, so you might say when manufacturing engineers and industrial engineers, they have two sides to the game, two kind of responsibilities. One, to optimize the current processes, what you do, so that your resource depletion is less. You are not only helping this, you are helping all three bottom lines, right? And on the other hand, you should look at what are the leapfrog, what are the game changers, so that you can completely get rid of some processes, right? For example, look at our industry. We get a big fabric roll, then we cut it into pieces and assemble again, right? So if you really look at it, this is totally against your lean manufacturing systems, but that's how the industry has been made. If you look at our industry, we do everything in batch processes. So the person who make yarn, spin yarn, do it in batch sizes, which is most economical to them. The one who knit fabric, do batch sizes most economical to them. One who give color to fabric, color them in the most economical batch size they want to. But it is not how consumers purchase a garment. We just take 1 or 2 garments at a time. So can we do this N=1 sustainably? Then that is where, at the cost of a mass manufacturing, if you can do N=1, we believe that is a great win, so that you don't have this waste. So there are different aspects of this when you say environmental sustainability. So there are different aspects and there are different projects aimed at this, Rajiv. So as an industry, the biggest thing that I see is overproduction, overprocessing, because you know that there are so many garments that's going to the consumer, but then not that every garment is sold. There's a lot of disposal, or even at a discount rate that garments go out because nobody wants them. So there's a huge waste there. And then there's because they are not long lasting, there's a huge waste there. And then because they're only used once, they cannot be recycled because the way that they have been made, there's a huge waste there as well. There's a huge pollution there. So these are different aspects. So we are targeting to solve these different aspects. Again, it is not just manufacturing engineers and industrial engineers coming in. That is a key message that I would like to say, that we have to collaborate with material scientists. We have to collaborate with chemists. We have to do this together to understand how to create a sustainable business. It's not an engineering problem alone. It's much bigger than that. So we have to collaborate and find solutions here. Did I answer your question? So anything else you want me to elaborate?
Very much, even more actually. It was very much eye-opening to me, most of what you said. And so yeah, thanks for all that insight. And I think you gave it you gave a different flavor. You added a different flavor to the whole concept of sustainability that I knew of, and how the value that a business brings to it, and how that value is actually required. Because like you rightly mentioned, as you mentioned, most of the younger generation is very concerned about sustainability and buying sustainable products. So of course you did answer my question, and thank you for that. And highlighting something that you just said about reducing waste, about the innovative projects carried out by you and by many organizations. We try to find different means and ways of reducing overproduction, overprocessing, and trying to find different ways and means of making the product and the process sustainable. So my next question actually is directed to Mr. Maleen, who is, as I mentioned before, he is into robotics and artificial intelligence. That was his area of study. So how does, and also just to highlight this, robotics, artificial intelligence, these are concepts, and these are new technologies that are taking over the manufacturing industry and many things in the world at present. So Maleen, how do you think robotics, artificial intelligence, these concepts, how do you think these concepts and these areas of studies can fix the problem? How do you think it relates to sustainability?
Yeah, so thank you, Rajiv, and thank you all the other panelists, as well as the final year projects that we all saw. They were really impressive, and I'm very happy having just gotten out of uni 4 years ago to really see all this great, innovation and ideas and research coming out. It's really, really fascinating and exciting. So to answer Rajiv's question in terms of robotics and as well as all this new artificial intelligence technology, I think robotics started in manufacturing. It's been, because of the controlled environments that factory environments provide, we've seen a lot of robots kind of get their beginning in manufacturing. And it's only now that we're starting to see these robots kind of come out of more controlled environments to more chaotic environments like, the road, where we're seeing self-driving vehicles and things like that coming out. So there's been a long tradition of robotics and automation in factory environments. So I think for us to tie this with the concept of sustainable manufacturing, I think the more efficient we can make our manufacturing, the less waste we can avoid, and therefore obviously move towards a more sustainable future. So I think these deep learning algorithms, for example, can really help us optimize our manufacturing process. Robotics can make our manufacturing process much more efficient. So in terms of those aspects, I think these technologies can really help by creating efficiency and reducing waste. I think we can contribute to more sustainable manufacturing. So that's how I see like how these technologies can contribute to a more sustainable future.
Thank you, Maleen. Thanks a lot. Thanks a lot for your insightful additions. And also, so we spoke about, Maleen, this question also goes to you. We spoke about renewable, the concept of renewable energy was highlighted just a while ago. And so, and actually the spike of the demand for renewable energy has also increased given the scarcity of fossil fuel, which is not far away. And also in general, in terms of climate change, it is definitely an area that is looked into. So how do you think Sri Lanka fits into the scope of renewable energy? What areas of renewable energy do you think Sri Lanka has to focus on, according to your understanding?
So being close to the equator, solar is a big push that we need to really make. And I think the cost of solar panels and solar energy has drastically reduced in the last 10 years or so. So I think heavy investments in solar as well as wind, and I've also been reading a lot on tidal based energy, which is really picking up as well now. So I think those multi-faceted approaches, I think, is the best way to go forward, because especially when it comes to renewable, you need sort of multiple approaches to make sure that everything has a fail safe essentially. So I think it's also important that we really push forward with that, because like the urgency of this problem is quite important now, right? Because scientists have been talking about climate change for the last 20, 30 years, but there's been a really slow movement on it, and we've come to really a tipping point, right? And just this year, there's been like so many floods, so many record-breaking droughts across the world. including Sri Lanka, right? And manufacturing is an important piece of the puzzle to solve this problem, and so is energy. So I think the fact that we are discussing it here is a huge step forward, because I remember when I was doing my undergrad, there was no discussion about any of these issues. And I think like technology really has the ability to radically affect society and affect our environment, right? And as engineers, we are the harbingers of those technology, and right, and we need to make it second nature for us to start discussing environmental issues and social issues. And I think this is a really great step that this entire panel discussion is centered around environmental issues and sustainable issues, because we need to really build that social consciousness in our engineers, right? And because we are at this point now where we're dealing with existential threats like climate change, that like by 2050, I think there'll be more plastic in the ocean than fish, for example, right? And they're really causing a lot of damage, not only to the environment, but to ourselves essentially. So I think it's really important that we talk about these issues and talk about not just in terms of the economic costs and benefits of this, but also the real impact on people, right? Individual people, and how these things affect our lives. So to circle back to your original question, I think it's really important that us as engineers push for all forms of sustainable energy that our country can really push forward towards, like solar, like wind, and tidal energy, as well as our hydro energy system, which is why it really doesn't make sense sometimes when we invest in more new coal power plants, when the entire world is moving away from these things. So I think it's up to us as engineers to push those things, because we can't expect our politicians to really understand or care about these things, right? So I think it's really important that we have more panel discussions like this, or at least introduce a subject in our curriculums, because really our ability to create technology has a huge impact on society, and we need to do it. With that power comes a lot of responsibility as well. So thank you for organizing this panel discussion, and yeah, I hope that answers your question.
Thank you, Maleen. Thank you for your insight. You definitely answered the question. And thank you all actually for being a part of this panel discussion and sharing your insight. So highlighting a few points that Maleen highlighted, you really stressed on the importance of taking action right away, because we are really in an existential crisis in terms of climate change and everything around it. So my next question goes to Mr. Priyantha, right? So as a factory manager, I'm sure that you have been a part of, and maybe you have driven sustainability drives. It could be in terms of renewable energy, or it could be in terms of reducing waste and whatnot. But in terms of renewable energy, if you have already if your factory has already implemented anything as such, or if you are planning to implement such a project or implementation, how practical do you think it is? Do you think the factories right now are ready for that? And do you think that investing on, let's say, solar panels would really pay off? Do you think that be a cost benefit, that be a benefit to the cost or the investment that we would incur in switching to renewable energy? So that is my question to you, Mr. President.
Yes, Rajiv. Yes, answering to your question directly, energy is a challenge for the moment, especially for the manufacturing entire process. You asked whether we have implemented renewable energy for the process directly. Yes, for answering to your questions, we have implemented renewable energy project, especially the solar power, but not in the whole way to holistic all operation, but in to some extent we are using. But in challenge-wise, it is a big investment and need a lot of supporting services and need to maintain. We need that kind of effort to keep that way in renewable energy. In other terms, you said minimizing the waste. That also main thing. I am representing the consumer durable industry as a head of manufacturing. We are looking at the waste reduction also in terms of energy, in terms of some raw materials like plastics. We are looking at that thing also. Saving energy in any terms of for manufacturing, it is ultimately sort of cost reduction. Even it talk about the sustainability, it is really the products we are manufacturing will affect the to the cost if we waste the energy. And in terms of waste reduction, that also come under the energy saving. Overproduction or excessive production or waste production is directly impact to the quality cost of the products we are manufacturing. As the it is a really a matter of the new technology or man involvement or machinery involvement or process involvement. We are focused on reduce the waste, especially for the plastic in my industry is concerned. Reducing reduce mean the waste minimization. We are conducting a lot of waste minimization projects handled by various departments, various personnel, and with that we are focusing on element level. Sometimes the machinery level, sometimes the malls level, sometimes the material levels. We looking at the every look and corners to reduce the waste. In energy terms, even we are using the solar, or that is the mainly possibility for the moment. We are using the solar energy, but in future also we have a big expansion in the quite good industry in all over the country, as well as the in our single industry also concerned. We have big projects going on. We have planned a lot of solar power usage in everywhere. Of course, now we are using only for the part of the manufacturing plant. We have planned to big factory setup, and with that we are going to do a big projects. Even it is challenging and cost price, it is a big investment. We have planned. And other way, another angle, even water, wasting water. That also we have big concern. Even the rainwater harvesting. For the moment, we are using as a part of the project in the entire operation. We are using the rainwater for some small operations, but we have planned it to in our big projects coming up. Big projects we have planned to implement rainwater harvesting also as a sustainability measure to save the energy. I think I answered to your questions.
Definitely, very much, Mr. Priyantha. I'm glad that Singer and your factory is already implemented and has hopes of maximizing it and further expanding the project. So on that note, I think we have come to the end of the panel discussion. We learned a lot of great insights, and I think it's literally impossible for me to summarize all of it into one. But if I am to just leave one takeaway with all of you all, it would be to really make this a point of discussion because it is, the climate crisis and the scarcity of resources we are really in a very critical stage, and we really need to act on it. We need to discuss about it. And even if you can't find courses, you can do your self-research, talk to people, and most importantly, please share the knowledge that you learned today. Of course, all these valued panelists shared a lot of insightful knowledge and experience. So please do go share these with your friends, family, and at university. And most importantly, it's important to really take action by yourself. We cannot wait and expect corporates and governments to take action. We also have a big part to play in this. So as consumers, as citizens, as a species, all of us are responsible for this, and it's very important to take action. So on that note, I hand over the screen to Kulani. Over to you, Kulani.
Thank you very much, Rajiv. Thank you very much to all our panelists and our panel moderator for that interesting 45 minutes that raised the bar of Industrio 2021 to a whole new level. Once again, that was our industry experts on manufacturing and industrial engineers' contribution to the sustainable transformation of the industry. Ladies and gentlemen, this brings Industrio 2021, the annual research symposium of the Department of Manufacturing and Industrial Engineering, to a close. At last, I would like to remind you that the proceedings of Industrio 2021 will be available soon on our website. Now, let me invite Dr. Achala Pallagedara, the President of the Manufacturing Engineering Association, to deliver the thanking note. Over to you, sir.
Thank you very much, Kulani. So it has been a long session, and I must reduce some of the things that I wanted to mention. And for being the conference chair, the symposium chair, and the president of Manufacturing Engineering Association, it's my privilege to have been asked to propose a vote of thanks on this occasion. So let me start thanking Professor Gamini Dissanayake. A big thank always to you, sir, and always big asset to us for his effort towards guiding, exploring, and motivating young generations of engineers, researchers, and connecting and bridging the gap, especially of the researchers and industrial requirements. And very big thank goes to you, sir. And next, I must mention our deep sense of appreciation, Mr. Jagath Jayasundara, who came forward as being the chief guest today, for his explanation of how innovative ideas are valued and important of surviving the context, current context of business, and how strategical decision making would change the business into next level of local and global context. So further, we are grateful to all the discussion panel members, Ms. Sithila, Ms. Dassanayake, Director, Technology Innovation, Twinery by MAS, and Mr. Sanjeewa Jayasundara, also Head of Supply Chain Management and Ceylon at the Ceylon Cold Stores by John Keells Holdings, and Mr. Priyantha Wettewa, Factory Manager, Regnis Appliances Private Limited by Zinger, Sri Lanka, and Mr. Thilan, Samarawickrama, Director and CEO, Ecofilms Private Limited, for demonstrating their proliferated ideas and experience through the journey in the industry. And I may like to express our friend, sincere thanks goes to Dr. Maleen Jayasuriya, who has been obtained his PhD in UTS Australia, for giving an excellent coverage of benefit of students who is to be in part of industry, and how the sustainability has to be adapted in their lives. And I wish to express my sincere gratitude to Dr. Asela Kulatunga, Head of the Department of Manufacturing and Industrial Engineering, for providing encouragement at various levels in the effort, and especially he was the hub connecting industry experts and industry research experts always. So he's one of the pillars behind the screen. And especially I would mention the Dean Faculty of Engineering, Dr. Dissanayake, who has been with us in the morning and who is always helping us to take the events in such level. And also I extend my thanks to Professor Emeritus Susantha Pathirana. Your presence is always inspired over the years, sir, to the department. Thank you, sir, for being with us today. And the story behind the screen, I just wanted to mention it quickly. And I'm also very grateful to Mr. Sumudu Lakkana for his endless support during this entire fete as the Vice President of Manufacturing Engineering Association, taking a lot of burdens and absorbing those seamlessly. And also the Mr. Pasindu and Mr. Tushara and Ms. Samira, especially setting up the connecting all together via webs and all designs and all. And also Ms. Dinusha and Ms. Rajiv and the team of proactive students who have helped in many ways with their endless effort to make this into great end. And a very big appreciation to Kulani Jayaratna. I'm really happy who came forward and giving a plausible delivery of comparing the entire session, and Mr. Rajiv also moderating the panel discussion lively, and thumbs up you guys, your commitments. And we also would like to acknowledge our gratitude to all the staff and student members of organizing committee and subcommittees, all the other academic staff members and non-academic staff members on the Department of Manufacturing and Industrial Engineering for helping us in many ways to take this symposium into in this nature. And we all inspired by your support as well. And finally, ladies and gentlemen, once again, I want to state that we are all most grateful to all speakers on the virtual forum and all the audience who have been posting and sharing thoughts throughout the session. We thank you all for being with us since this morning. It's been a great pleasure for us to be able to move into more activities in future as well. Thank you very much for your attention and your help, always valued us. Thank you very much again.
Thank you, Dr. Achara Palligidara, for proposing the vote of thanks and closing remarks for today's event. Let's call it a day, hoping that we would meet again in our future endeavors. Have an awesome rest of the evening, and wherever you are around the country or the world, please stay safe.